I'm Joyce Leiz. I'm Executive Director of the Connecticut Audubon Society, and I'm proud to be a partner of a group called the Connecticut Coalition for Pesticide Reform, which is led by Tara Cook-Littman. Please join me in thanking Louise Robert from Pollinator Pathway and President of Norwalk River Watershed Association, plus our other co-sponsors, Rivers Alliance of Connecticut, Sierra Club of Connecticut, Connecticut League of Conservation Voters, American Bird Conservancy, Save the Soundkeeper. Hey, Bill. Clean Water Action, Catskill Mountainkeeper, Laurel Rock, and East Norwalk Blue. In Connecticut, the main use of neonicotinoids is on lawns and golf courses. Golf courses represent between 8,000 to 12,000 acres in our state. So the impact of using neonicotinoids to do grub control on golf courses is really major in our state. But they have another use, which is in agriculture as well. Not as large of an impact in Connecticut, but still important to know that they're used on, they coat seeds with neonicotinoids as a preventative measure for insect management. 5% of that goes into the plant and 95% goes into our water systems. One neonic coated seed, stray seed that's picked up by a songbird is fatal. So we're very concerned about the impacts on our birds, bees, and butterflies on neonicotinoids in our environment. The shocking loss of 3 billion birds since 1970 has many potential causes, including increased use of neonicotinoids during that time frame, as well as increased pressures from climate change. Combined, we're seeing continued declines in our common birds across Connecticut. A recent article in the Washington Post documented the staggering losses across the nation. And they use eBird data for this. So we were able to drill it down to locations right here in Hartford. We've seen declines of 10% or more of common birds. Black-capped chickadees have declined 16%, red-winged blackbirds 12%, tufted titmice 13%, and mourning doves 10%. And many of our favorite, most colorful birds that rely on insects are cedar waxwing, 16% decline, common yellowthroat, 15%, and tree swallows, 15%. These statistics are devastating and are in part connected to neonicotinoid use in the state. At the start of the 20th century, Connecticut was a leader in promoting environmental legislation to protect birds and other wildlife. From the passing of the Migratory Bird Treaty Act in 1918 to establishing Connecticut's Environmental Protection Act in 1971, protecting Connecticut's environment and wildlife has been at the forefront of our attention. We at Connecticut Audubon have seen the success of some of these initiatives. We classified neonicotinoids as the new DDT. We all know what happened with DDT. The impact on eagles and osprey across the nation was devastating. But we've seen the return. Our osprey monitors now tracked about 700 nests with more than 850 chicks that are fledging annually. We would love to see these successes replicated for songbirds. Birds are charismatic ambassadors, and noting any decline is disturbing. Identifying and addressing as many causes for it is critical. We are on the brink, but we can make a difference by acting sooner rather than later. I'm pleased to be working with all of the members of the Connecticut Coalition for Pesticide Reform to address these issues. Together, we can make Connecticut safer for birds, wildlife, and people. And your presence today is an inspiration for all of us. Just a reminder, today we're using Slido to take questions. That way we'll be able to address questions both online and from the room. You can use the QR code that's on the screen to access and submit questions today. It can be used remotely as well as present. And if you're on Zoom, you've been sent a link as well. So feel free to use that link and ask and submit questions. Now I'd like to introduce Louise Robert, an agronomist and grain crop specialist for the Ministry of Agriculture, Food and Fisheries of the province of Quebec for 35 years. Mr. Robert was fired in January of 2019 for having leaked an internal memo to the press about the interference from the pesticide industry and the farmers union on research results that showed no benefit to farmers from the use of neonics. He was reinstated later that year after an internal inquiry by the Inspector General and received apologies from the Secretary of Agriculture and the Prime Minister. He retired 2 years ago and currently works as a consultant agronomist on issues related to soil health, pesticide and fertilizer use, phosphorus losses to waterways, and ethics in agronomic research. Mr. Robert, thank you for joining us today to discuss the Quebec experience from reducing neonic use.
Good afternoon to all. First of all, I'd like to thank the organizers of this conference for inviting me to share with you what we in Quebec have experienced with respect to neonics. As you might already have realized, I have a strong accent, so I only hope that you get 50% of what I'm going to say. Okay, let's get started. Let me begin by sharing two quotes, two principles underlying the experience that I'm about to present. The first one is taken from a scientific paper accounting for the failure of precision agriculture technologies to improve the net income of Midwest farmers. Good science starts with good problem definition, and good problem definition usually starts with the accurate observations on the system in question. In other words, using the basic scientific approach in problem solving, you must first of all, you must establish a sound diagnosis before implementing any kind of solutions. It may seem very obvious, but unfortunately, it's commonly overlooked, especially when it comes to politics. The second, I borrowed from the American writer Upton Sinclair, goes like this: it is difficult to get a man to understand something when his salary depends upon his not understanding it. Now, this is a lesson I learned very early in my career. After after hearing me talking about fertilizing and manuring, some farmers would come up to me and ask me to talk the company representatives into telling the same story as me, so that we would all sing the same tune. I knew right away that that would be impossible. It would be beyond the scope and the skills of a very young yet ambitious agronomist that I thought I was anyway. The company reps do not stand for farmers' interest or the public interest, but only for the company he or she is working for. That is what he is concerned with, period. And they are doing a pretty good job at it. No blame to them from my part. They have always been, those representatives, been ready to go to great lengths for that purpose, to the extent that some of their attempts look extremely far-fetched, as the following two short videos will show. This first one dates back to the 1940s, when a group of British scientists went as far as eating porridge sprayed with DDT in an attempt to have African peasants use the first human-made pesticide, insecticide.
Some are afraid that the DDT will poison them, while others suspect some sort of witchcraft. The entomologist calls for a bowl of porridge. This is sprayed with the solution in full view of the audience. He now eats several spoonfuls of the mixture to show that the contaminated food is harmless.
Oh my God.
Even this fails to convince the audience.
They're not convinced.
Arab Kipkoy is the chief spokesman and states his objections with eloquence. He says that the new medicine is a bad poison that may exterminate the whole tribe.
In a similar fashion, but 68 years later, in 2015, a Canadian scientist Formerly environmental activist turned pesticide advocate, was caught on camera on French television, making yet again the same absurd claim.
I do not believe that glyphosate in Argentina is causing increases in cancer. You can drink a whole quart of it and it won't hurt you.
You want to drink some? We have some here.
I do not believe that glyphosate in Argentina is causing increases in cancer. You can drink a whole quart of it and it won't hurt you.
You want to drink some? We have some here.
I'd be happy to, actually. Not really, but
Not really?
I know it wouldn't hurt me.
If you say so, I have some glyphosate.
No, I'm not stupid.
Okay, so you.
No, but I know
so it's dangerous,
I know. No, people try to commit suicide with it and
but
fail fairly regularly.
Tell the truth.
It's not dangerous to humans. No, it's not.
So you're ready to drink one glass of
No,
glyphosate?
I'm not an idiot. Interview me about golden rice. That's what I'm talking about. Okay, then it's finished. Then the interview is finished.
That's a good way to solve things.
Yeah.
That's it.
You're a complete jerk.
Now, if you are the kind of person who always look for the bright side, you may say, we've made progress over that 68-year span. At least now the pesticide people no longer drink or eat their products, even though some of them may still pretend they'd be willing to. On a more realistic note, one can't help but come to realize how little progress was actually achieved. You probably know this lady. Despite the abundant scientific evidence brought to light in a magnificent way by the groundbreaking biologist and whistleblower Richard Carson as early as 1962, as you all know, the pesticide usage worldwide has only gone up since, exponentially since the advent of GMO crops in the late 1990s and its reliance on glyphosate. Much of this increase in use is due to large part to our willful blindness, naivety, and the failure of our institutions and their managers to take up the task that they were paid for by the public. We've got to make once and for all a move and part away from the industry's rhetoric and put public interest first. It's long overdue. Now, getting toward the topic of the day, let's look now at the picture in Quebec. In Quebec, we grow around 1 million acres each of corn and soybeans, 600,000 acres of small grains, and 100,000 acres in vegetables. We use a little bit over 5,000 tons of active ingredients, of which 3/4 of it is used in the agricultural sector. In 1992, the Ministry of Agriculture, together with the Ministry of Environment and the Farmers Union, agreed upon a plan aiming at the reduction of 50% of the amount of pesticide. I just laugh about that. 50% of the amount of pesticide used by the year 2000, 8 years down the road. It had no effect. The plan was resurrected with lesser, more humble objectives in 2011 and again in 2020. No effect. The conclusion, obviously, is that the incentives and extension work don't actually work, but no one ever stopped and wondered why. This chart is taken from the latest annual pesticide sales report put out by the Ministry of Environment. It showed the total amount of pesticide used in Quebec across all sectors in metric tons for every year from 1992 to 2021. Clearly, there is no downward trend. Take note also of the record sales of 2021 and the complete lack of effect of our 4 successive so-called action plans. Looking more closely at the farm sector now, this top line shows basically the same thing as the previous one, but just for the farm sector, 3/4 of the total for all sectors. On this one, we kind of see that the upward trend seems to have leveled off or even declined somewhat in recent years, at around 3,500 tons in 2021, which 50% is made up of glyphosate use. Glyphosate use accounts for 50% of it all. So that leveling it off, whoops, sorry, shows that the consumption of other sectors like forest, golf courses, and domestic use might have picked up and explained the continued increase in the record sales in 2021 that we just saw on the previous graph. During that time, monitoring by the Ministry of Environment in Quebec reported that pesticides were detected in most, if not all, streams and rivers, and in increasing concentrations, especially for neonics. Scientific evidence of the toxicity built even stronger. For example, a French researcher in 2010 reported that the toxicity of neonics for honeybee was several thousand times that of DDT. Toxicity of neonics, that is, for honeybee, was a lot more than that of DDT. As it was already mentioned, as little as 1.5% of a neonic called poncho actually entered the plant and reached target. All the remaining product was left in the surrounding soil, water, and air. Neonics are suspected to be a major cause of colony collapse disorder and pollinators decline. Public concern grew stronger in Quebec, as it is the case, I imagine, here too, in terms of environmental impact and public health issue as well. Most importantly, public-funded research showed no significant benefit to farmers from the use of insecticide-coated seed in 84 field crops trial. And this was published in 2020. This is, oh. Okay. This is not for you to read, of course. It is just the front page of that paper. It's the now famous paper issued in 2020 by the extraordinary group of researchers led by Geneviève Labbé in a highly regarded and renowned scientific journal, +1. I might add too that it's an open access article, so that it's free for everyone to reach, to have access to. And I think it's worth spending some time looking into it, as it was at the center of our journey, excuse me, leading to the reversal of the long-term trend of pesticide use upward until then. And by the same token, this research also called into question a number of popular beliefs, like, for example, what's the position of the Farmers Union with respect to pesticide? Do public funded research really achieve what it's supposed to? Among other things. Let's go over some of the, first of all, the materials and methods. This study was carried out during 5 consecutive years in 7 different regions for a total of 84 site years. And the researchers, to start with, selected the sites, especially those that were prone to damages, in a ratio of 1/3 approximately. Each site was treated as an independent trial, statistically speaking. And the only factor that was being evaluated was the use or not of neonic seed treatment. And it was repeated 3 times in each field. Now, as for the results, the target organisms, target species, the wireworms and seed corn maggots, were present in all sites, sometimes in large numbers, but there was no effect of the seed treatment on the insect counts, the larvae that were caught in the traps, in other words. So they were basically the same in plots that were treated as opposed to the plots that were not treated. Sometimes the treatment reduced the number of damage seedling, and that was the only significant effect, sometimes measured, otherwise no significant at all. But there was no effect whatsoever on the plant population, number of plants per acre, nor on the grain yield. And the researchers concluded that the results were true for all seed insecticides, because it wasn't a matter of type of insecticide. The damages were not even there to start with. And during that time, the researchers had to suffer quite a bit of industry and farmers union interference that translated in having the publication result hindered and me fired. And throughout the study, the industry and the farmers union maintained fabricated 5% risk. Because of the ongoing stranglehold of the farmers union and that of the industry on the research center, the working environment at the research center worsened over time. And for the last 10 years, personnel turnover at the center was that of a fast food joint. It was not before the resignation from the center that Genevieve and her colleagues were finally able to publish this article. And even then, the pesticide dealers, as I said, kept claiming that there was a 5% risk of yield decrease, and based on that, no farmers should consider abandoning neonic seed treatment. This 5%, in fact, stemmed from the number of site years where a large number of insects were caught in the traps. But again, no consequences were measured on yield, even on those sites. Now, before some of you might think that I'm a conspiracy theorist, let me show you what the General Inspector of Quebec found out after a 4-year inquiry looking behind the curtains at the research center. General Inspector in Quebec is called Protecteur du Citoyen, and that body published a report in last September. They had identified the main culprit as being the chairman of the board of directors of the public funded research, who, by the way, happened also to be a director of the Farmers Union, still is there, and he, at the time, was a registered lobbyist for the pesticide industry. Those are not my words. You can refer to that. It's publicly available. That individual also misled the farming community with respect to the effectiveness of neonics, and he ended up building mistrust towards public research and researchers. The Department of Agriculture, where I used to work, was not clean at all. The Inspector General mentioned that the negligence and misconduct of the Department of Agriculture made it an accomplice in that whole story. Now, as spring 2019, the Ministry of Environment made it mandatory for anyone wishing to use neonics to produce a written recommendation from one of the province's 3,300 registered agronomists. It had some huge effect, as you can see on the table. Major reduction, over 90% reduction in the 6-year time span. And almost, there's no neonics being used in Quebec to speak of nowadays, less than 0.5% of the acreage. Very proud of that, yeah, that's right. This table shows the pesticides commonly used on Quebec farms. Despite the fact that on a pound-for-pound basis, insecticides like the neonics are in general a lot more toxic than herbicides, I think we should extend our efforts to encompass all pesticides when it comes to reduction of their use. All of them are toxic, and because one is reportedly more so than others, should not make us more indulgent to the others. For example, glyphosate is now detected in organic commodities, and even, as Dr. Seralini from France reported, they found traces of glyphosate in the muscular tissues of penguins in the Antarctic. So the overall risk on health and environment is a product of toxicity and quantity being used. In Quebec, the government went to great lengths in providing visual support tools for agronomists and growers alike. The headline of this flyer reads, "Coated seeds, do you really need this cocktail?" And it outlines the most common fungicide and insecticide. There's a pointer here. Oh, here, okay. That the seed supplier were using with their relative toxicity ratings for human beings, aquatic organisms, fish, and honeybees. Traditionally, corn seed, as it was delivered to farmers, carried at least one fungicide and one insecticide. That was at least the standard in the intensive way of growing corn, which was generally the case in Quebec. I would say, I was gonna say until 2019, but even now, it is used on a large acreage. Practically, there are two strategies that one can use to get rid of pesticides altogether. The agronomic way, like this one, the on-farm strategy, and going through legislation that I'll discuss later on. Now, if I was going to suggest a practical approach for a farmer to cut back in his pesticides, I would first sort the pesticide he currently uses with respect to their documented usefulness. That allows the breakdown of the whole process into different time horizons. Please take note that from my point of view, there are no such thing as essential pesticides. It is just a matter of time and access, having access to competent agronomic support. For example, I know for a fact that spraying a blanket type fungicide treatment on a whole field, as it is sometimes the case now, ahead of any occurrence of symptoms of diseases makes no sense once you are aware that the specific weather and soil conditions of your field keep the risk at bay anyway. Given sufficient competent and unbiased advices to farm managers, it would not be difficult to achieve significant short-term advances on a voluntary basis. But unfortunately, that is precisely the problem that we had in Quebec, and we still have. And why the agronomic method kind of failed over again and again, and why we in Quebec had to wait a long time until the regulatory approach by the Ministry of Environment in 2019 to achieve any kind of success. And it turned out to be fairly successful, at least with respect to seed insecticides. Out of the 1 million acres of corn grown each year in Quebec, my own estimate is that a little less than half will no longer carry any insecticides at all this coming season. And it will have to spread very fast to new areas in the very near future, because the justification of need requirement will be extended from neonics to all insecticide as soon as next year, and to all seed chemicals by 2027 and 2028. And so far with little impact on the agronomic outcome. The Crop Insurance Agency reports of no crop failure and not even yield reduction due to the lack of seed treatment. Some cases from time to time are brought up, but after a closer look by the agronomists of the board, there were no cases that could be traced back to the absence of seed treatment. Other factors that are bringing about this reduction also include public pressure. In Quebec, probably the case here too, we feel enormous, huge amount of pressure from the public for pesticide reduction. And it's a phenomenon that we observe since the last 4 or 5 years maybe. And also the fact that the proof is very obvious with 400,000 acres of insecticide-free crops. and the yields is maintained, if not improved. So it's very obvious that there's no harm being done there. But I would be lying, oh, Mr. I would be lying to you if I were to say that everything went smoothly. First of all, initially, the seed companies merely swapped the chemicals from neonics to diamides, which may be less harmful to bees, but no more useful and way more toxic to all creatures living in the rivers and streams. Their only advantage, that is of the diamides, being that they allowed farmers, for some time anyway, to break free from the regulations. And the diamides were soon detected in the water, and now almost all analyses show at least traces of them. The very recent changes in the practice, sorry about that. The very recent changes in the practices at the farm level can't be seen just yet in the official sales reports, which pulls the public trust downward still. And not the least, research and alternative methods like integrated pest management are being overlooked. The true question that I'm keep asking is, how come, from an agronomist point of view, how come we must turn to legislation even when such toxic compounds show no benefit to farmers? Explanation stems from two basic causes: industry and farmers' organization interference, and too few extension agronomists. That is my diagnosis anyway. Now I'll show you some charts, figures of, this is the evolution of the detection frequencies of the main pesticides in the rivers of Quebec ever since the year 2000. Now you'll notice the trend, very obvious trend for replacement from neonics to diamide. It almost happened overnight. And the same with the conventional herbicide for the benefit of glyphosate on the upper right corner. You see glyphosate in terms of detection frequency is close to 100 now. Yeah. So it's a problem that we displaced actually, but the problem is still there very much. And now for the concentrations, we can see on the left figures that all three neonics have seen their concentrations down ever since 2000. And on the other end, that of diamide increasing at the same time. And glyphosate in recent years has kind of leveled to a plateau, which is good news, but it's still quite high in terms of concentration too. Now, I'm getting near the end. If I'll be ready for question, I think we have time, but I just want to show some examples of IPM, integrated pest management, at work on the farm. Those pictures were taken last summer. The farm of a leading farmer in Quebec. He switched from full width herbicide spraying to narrow strips, just applying herbicide on the corn rows or the soybean rows. Those are the nozzles that we see on this planter right here. And in combination with that, he just runs this mechanical weeder in between the rows. That way, and he's very, very satisfied with it. He's very happy with it. He cut his pesticide bill by more than half. So this is IPM at work. Another example of IPM is the use of intercrops and cover crops. This example here shows corn rows with ryegrass interseeded. Any kind of cover crops or intercrops will improve the biodiversity of the field, which in turn will keep all the pests, will reduce the pressure from all pests around, insect, weed diseases. So it's a logical move for anyone wishing to reduce, it's a must actually. Try to increase the biodiversity by using cover crops as often as you can. And from different species as well. I'm just about, reaching the end now. Okay, another more radical manner or method is to plant soybeans directly into standing winter rime, sorry. And this crop rotation will allow farmer to get rid of all pesticide. He doesn't need any pesticide in that sequence. The mulch provided by the standing winter rye is so thick that there's no wheat that can germinate. And also it keeps the disease because of the diversity. There's no more diseases on the soybean, so on and so forth. A lot of benefits, but on the other hand, a lot of work in fine-tuning his system because of the equipment adjustment and all that. It's not given to anybody. But it's a reality. It's working now on some farms in Quebec. And a key component of IPN, of course, is scouting and agronomic services, which are making a comeback in the Quebec landscape, and that's a very good news. At the end, the farmers themselves are the ones that are the best advocate for biodiversity, cover cropping, like this one, Mr. Quentin showing is the soil profile, the soil texture that is being so much improved by the use of legume cover cropping. This is a what we call a soil profile, just we dig in the field to look at the different aspect of soil texture and structure. And extension events like this soil health caravan that we called at the Department of Agriculture. We ran more than 150 such events throughout Quebec and even in different provinces in Canada. It's very efficient to transfer the information. Okay, getting to my conclusion. Again. Thank you. Legislation has limitations. From my point of view, anyway, we should not pinpoint Neonics because we're going to put pressure on the companies to use other kinds of pesticide, insecticide. All pesticides are toxic and we can farm without any. Agronomic objectives, and this is contrary to public belief. We usually think that in order to reduce the environmental impact, we must sacrifice some yield, which is not true at all, based on scientific research or agronomic research. Agronomic objectives are always in line with the farm economics and with environmental well-being, including health issues. Agronomic standpoint alone, phasing out of pesticide makes complete sense, and the adoption of basic agronomic research results like IPM could bring about a short-term reduction of more than 50% in the use of pesticide. But unless our extension system undergoes major adjustments, we will keep relying on legislation. And that's it. Thank you very much for your attention.
I have back here. We do have some questions for you. Quite a few questions. So Joanne asked, if a property owner has had their land planted with neonicotinoid coated seeds in the past, what is the best way to bring that land back to good health?
Well, on a lease, an owner in Quebec, anyway, a proprietor of land can specify no neonics being used on my land or no pesticide altogether. Mind you, there are not too many that are doing that, but it's possible. But I would also emphasize that soil health does not depend solely on the use of not of neonics. It's a global, it depends on all kinds of different factors. Soil tillage, for example, is one major. It's all intertwined, actually, And that's why I say that targeting one sort of pesticide, especially, to me, it's not very productive. We're not going to improve much our soil health and our productivity and so on. We have to tackle all from my point of view, all issues at once. But it would be, I'm sorry, but it would be, as I said in the presentation, my talk, it would be a nice first step, because it's very easy to remove all seed insecticide. That would be a very logical first move, because the farmer will see no difference whatsoever. And remember that farmers are first-hand exposed to the product, to the chemicals, so they're willing to do that. Just a matter of fact, they've been brainwashed, in other words. All those years.
Well, it's inspiring to see them changing their practices in
Yes,
other,
yes.
in other parts of North America. We had a question about neonics and the chemical or other chemicals that might have been implicated in the mysterious bird illness we had several years ago, and I'm not sure that that was neonic, because that was a contagious disease, and that.
Sorry.
Are neonics being used for tick control? Okay, so I think I have the answer for that one. So neonics are used in dog collars for tick control, but they are not sprayed on plants for tick control. So they are not mosquito or tick control out in the field.
Yeah, I can complement that with findings from research says that say that neonics, not even the farmers are controlled by neonics. Actually, our main insect pests like soybean aphids and others, rootworm, corn rootworm, are not controlled by neonics. Not at all. They escape because they're not timing stuff right.
So then, someone asked, are seeds treated with fungicide more expensive?
Usually they get a rebate of 10 to 20 Canadian dollars per bag, bag of corn seed. Sometimes there's no difference, but it's never more expensive to.
So basically, the coated seeds are subsidized.
Right, yeah. Well, I mean, right now in Quebec, we have a program that pays, I believe it's around $40. That would be $18 per acre, Canadian, American dollars per acre, US dollars per acre. If a farmer is not using any insecticide right away, he's eligible to a program where he gets a reward from the government for not using insecticide.
Does the US have similar employment model for agronomists?
I don't know. I can tell you.
This one, how long does toxicity persist in the soil after pesticide usage is stopped? How long does it stay?
Right, yeah, this is a good question. There's a study in Canada that says that after stopping from using atrazine is a very residual herbicide. It takes at least 20 years before you don't see any more atrazine in the soil once you've stopped the grinding. On the other hand, glyphosate is very is short-lived in the soil. It's being degraded into a product called AMPA, A-M-P-A, which is residual, but it's not as toxic as glyphosate, but we find it everywhere too. So it depends on the chemical, but neonics are they're persistent in the environment. If it's not in the soil, then it's in the water, in the puddles too, in the field. That's where the bees come to drink sometimes. That's how they get intoxicated.
Are there any appropriate and safe uses for neonicotinoids?
No, not that I can know. Well, they're toxic and they're useless, so not bother.
We have a lot of questions on the how long it stays in the environment, and I think you've covered that a little bit.
Yeah, as I showed some graphs, the neonics in the water, it's going down, so it doesn't take very long to go down, but they find traces of it for a long time. but at least not as often and not as concentrated as it used to be. 4 or 5 years ago, neonics were everywhere, in every river at high concentrations.
So this question, I'm not sure if it's for you because it's about golf courses. Are neonics used on golf courses, and what are the non-neonic options for golf courses? So the answer is, in Connecticut, yes, neonics are used on golf courses for grub control. However, it has been shown that they're not effective on grub control. So there are other options that they could be using, including nematodes, as well as some other items. They are on posters or around the room of what some of the options might be. Please clarify the meaning of poncho in the statement of 1.5% of poncho reach target. It's from your presentation.
Pancho is a brand name, a commercial trademark. The real name is chlorothianidin. It's one of the three that I have on the graph. One of the three neonic. It's a neonic Pancho. Like the other one is sombrero is another one. They have commercial names that I don't know why they have a Latino origin. I don't know.
And final question, since pesticides are expensive and useless, why do farmers continue using them?
Basically, because they were told for so long that by the pesticide representatives, you know, when you're managing a farm, when you're a professional farmer, you get at least 8 to 10 visits from representatives during a month. So they're very much, you know, they're very much solicited by the industry and to buy products, and they've been told over and over again that they would lose their yields if they're not using the product. So, and because of the government in Quebec, anyway, the government withdrawal from that whole area of extension and advices to farmers, then the field is wide open for the representatives. So in the long run, you know, farmers just believe it. They've been telling that message so many times. That's for them, it's the truth. But now we're trying to undo that. And it's going to take, well, we've made really good progress with the legislation, but other, like the general inspector report, kind of opened the eyes up to a lot of people in Quebec, I can tell you that, yeah. And it's not finished.
Couple of more questions. Are there existing studies of neonics causing other problems like the proliferation of hydrilla in the water systems?
I'm sure there are plenty of literature showing adverse effect of neonics on all kinds of living organisms. But I'm not, you know, I didn't go into that because I've not much anyway, because I'm an agronomist basically. So I presented the view that my conclusion, but I know that there are plenty of harmful effects found, not only from neonics, but like I said, diamides. In Quebec, we have a good, it's an online tool that everybody can go to and type in either the brand name or the scientific name of the pesticide, and they get all kinds of information about the toxicity to the damage to the environment and the toxicity for humans, toxicity for animals. It's all on the site. It's very useful. Mind you, it's in some cases it's not up to date because there's new information coming up almost every month. And the more we learn about, for example, glyphosate, the more references we find about the toxicity of glyphosate, which we did not suspect at all. Like the fellow I just showed earlier on in my talk, you know, a lot of people were handling glyphosate or herbicides in general with bare hands, no protection whatsoever. Nowadays, you won't do that anymore. The consciousness is widespread now in Quebec. Not perfect yet, but it's we're much more concerned about the effects of all. Like I said, from my point of view, on a pound for pound basis, some products are way more toxic than others, but they're used in so lesser quantities than the glyphosate or pursuit herbicide. Is in other words, they use chemical herbicide. So the quantities are 10,000 times that of neonics in terms of kilograms. And we find that glyphosate and ample is in the city of Montreal. And as a matter of fact, you might not know that, but the city of Montreal passed a bylaw 2 years ago forbidding glyphosate on its territory for domestic usage and golf courses, anything. We can no longer use glyphosate on the territory of Montreal, the city of Montreal. So that made a lot of noise in the farm sector.
We've had a few people ask for the website that you just identified.
Yeah.
So if you share that with us, we will make sure that we get that out to all of our participants today.
It's in French.
And that was the other question, was is it in French? Google Translate. Thank you. Always inspirational when you hear farmers taking initiative to protect the environment. And as Mr. Robert noted, farmers are the front line. They are exposed to these chemicals. They are concerned for their own health. And so the more that we can increase awareness of what they're utilizing on them and the environment, they are really friends of the environment when they realize. Now I'd like to introduce John Tucker, professor and extension specialist in the Department of Entomology at Pennsylvania State University. Professor Tucker's research group studies relationships among plants, invertebrate herbivores, and natural enemies to understand factors that regulate populations of herbivorous insects and slugs. The long-term goal of his research is to exploit ecological interactions for sustainable insect pest management. Thank you for joining us today to provide an overview of the problems associated with neonics, including ecosystem disruptions and natural solutions. Thank you, Dr. Tucker.
Yeah, my pleasure. Sorry I couldn't be there in person. Wasn't very convenient for my family, so here I am in Pennsylvania. But I can reveal that I'm a Connecticut native, so it's nice to at least be beamed back into the state. Still have family there, but they don't invite me very often, I guess. All right, so I'll share my screen and get started, and I won't go on a lengthy diatribe of my family. All right. All right. Does that look all right to you guys? You can see that? Okay, great. All right, so my goal today is to talk about some of the research we've done on neonics, but I'll kind of start with a basic introduction, and then I'll get into kind of use patterns. And I think the use patterns are relevant to conversations that are going on in Connecticut that were kind of shared with me. And then I'll go into some kind of non-target effects and some of the things that we found. And I'll wrap up with some questions. I'll keep an eye on the clock here so I don't go over. But neonics are synthetic compounds, but they're inspired by nicotine. So was someone yelling at me for doing something wrong? No? Okay, I'll keep going then. So if you remember your Greek roots from your language classes there in the fine Connecticut school systems, neonicotinoids are just the new nicotine-like products. Nicotine is the inspiration on the left, and the most popular neonic on the right is imidacloprid. And these have been around for a while, as I say, first introduced in 1992. And here are kind of 6 of the most common active ingredients. They're kind of an alphabet soup, but I'll just say them so we're all on the same page. There's imidacloprid, clothianidin, thimethoxam, dinotefuran, acetamiprid, and thiacloprid. And I'll just focus on these 6. There are a few more, but not that many more. And it's quite relevant to recognize that 3 of these are coated on seeds. So that's imidacloprid, clothianidin, and thimethoxam. The seed market is dominated, however, by the 2 in yellow. So clothianidin and thimethoxam by far are the most abundant on seeds, even though imidacloprid can still be found. So just kind of keep that in mind. And we want to keep that in mind in part because of the toxicity of those three compounds. This figure is from some colleagues at Purdue University. It's a table in one of their publications. And it just shows the toxicity of 5 of those neonics relative to how much it takes to kill a honeybee. Now, honeybees here can just be thought of as a test organism. And it takes very little of those 3, thimethoxam, clothianidin, and imidacloprid. So this is the amount that's taken to kill 50% of the bees in a sample. So if you have 50 bees in a sample, this is how much it takes to kill 25 of them. So thimethoxam, only 5 nanograms, clothianidin, only 4 nanograms, imidacloprid, only 3.7 nanograms. And that's through oral exposure. If we're talking about, and so that's if it goes in the bee's mouth. If it just gets on their cuticle, we need a little bit more to kill them. But recognize that these 3 that are coated on seeds are quite different from acetamiprid and thiacloprid, where you need orders of magnitude more to do the same damage to bees. So the message here is that these 3 are inherently different, and recognize that imidacloprid has a wide range of uses, but thimethoxam and clothianidin are almost exclusively coated on seeds. Okay, so they're different. Neonics are not a monolith. There is variability within the class. Okay, so these acetamiprid and thiacloprid are heavily used by vegetable and fruit production, and they have pretty good environmental profiles compared to those 3. All right, just keep that in mind. So neonics are nerve toxins. They work by mimicking neurotransmitters. And you'll recall from your biology days, I'm sure, that in our bodies and the bodies of other animals, we have these networks of nerves, and these nerves need to talk to each other. So one nerve cell needs to talk to the next nerve cell in the line, and the neurotransmitter is what does that communicating. So these neurotransmitters are going to go from one cell to the next, kind of relaying the information. And this is where the neonics bind. So they bind very well to the nicotinic acetylcholine receptor. Okay, so just recognize they're nerve toxins and they're mimicking natural compounds. As I say, these neonics are being used in a wide range of applications, and they have kind of fun names. I just arranged some of them from kind of A to Z here, and just kind of list their use. So they're mostly used on fruits, vegetables, and as seed treatments, but they can certainly be used as pets, as I heard earlier in turf. So they're certainly used on golf courses, as I heard in another question. But their use is mainly driven by crop chemicals. So these data are from the state of Minnesota. Very few states make these types of data available. So we borrowed them from Minnesota to make this figure, and it shows the amount of neonics on the vertical axis used over time in different classes of usage. So crop chemicals, turf and ornamental, lawn gardening, etc., animal care. And you can see that those different colors, like turf and ornamental or garden and lawn, are just kind of a veneer on top of the crop chemicals. So neonic use is being driven by crop chemicals. And within crop chemicals, it is the seed treatments that really drive their use. So again, these are compounds that are inspired by nature, but they're most widely used as seed coatings. And if we didn't use them as much as seed coatings, it's pretty sure to say that we wouldn't have some of the environmental concerns that we have. Right, so they are somewhat selective. They are very toxic to insects. They are among the most toxic insecticides that have ever been produced. So they're really bad for insects, and that's not good for the insects that we like. But they're milder on spiders and mites. They don't do very well against mites, but we want to keep a lot of spiders around, so that's a good thing that they're somewhat mild on spiders. They have putatively low toxicity to mammals, and that toxicity is based on traditional toxicological expectations. But some mammals are having a weird reaction to neonics that's not reassuring. And then they are unclear. There's unclear toxicity to fish and birds. It's really variable kind of among groups of birds and fish, but there is high level of toxicity in some cases, and it hasn't been sorted out what yet is causing that variability. So if we use them as seed coatings, they can provide a benefit, right? So they can target what's called secondary pests. They're coated directly on the seed. When that seed's put into the soil, capillary action takes that water-soluble insecticide out into the soil. And then when the root starts to grow, the plant can take up the insecticide systemically. Okay, so the insecticide runs systemically in young plants, and that can be a good thing if you're trying to control some pest species. It has systemic activity for 2 to 3 weeks, and that's providing protection against pests when these plants are young and vulnerable. Again, it appears to be low mammalian toxicity, and it certainly has less mammalian toxicity than other classes of insecticides like the organophosphates or the organochlorine. So neonics were a step in the right direction in many ways. And neonics appear to have few costs when they were originally introduced as seed treatments. Folks thought there was very little potential for impact on natural enemies because you're putting most of these things in the soil, and like, how's that going to get out and influence natural enemies? And enthusiasm was so high that this paper that was authored by some industry-based scientists used this sentence, which is alarming, that seed coats allow for an environmentally safe and perfect protection of young plants against insect attack. I think from some of the information you probably already have and some of the information I'll share today, we know that the word perfect is incorrect there. And I try to encourage my graduate students not to use the word perfect in their scientific publications. So as seed treatments, they haven't been around for that long. Though as the previous speaker just indicated, there's been so much marketing around them, it's difficult to forget that they weren't around before the mid-1990s. So imidacloprid, commonly called gaucho, thimethoxam, commonly called cruiser, or clothianidin, commonly called poncho, were only introduced in the mid-1990s to the early 2000s. When they're used as seed coatings, they have different rates that go on individual seeds. So in corn, the low rate used to be 0.25 milligrams per seed. And in soybeans, the low rate is about 0.07, so a good deal lower than what's on corn. So just kind of keep that in mind, that there's a difference in the rates between corn and soybeans. And this is the general idea of what we hope seed treatments will do. If they provide this kind of halo of protection around your vulnerable seed, and that halo of protection is taken up into the young corn seedling in this case, protecting it from the inside. That's the general idea. So let's think about some of the limitations. Some of the limitations are that those yield benefits are strongly inconsistent. Previous speakers certainly mentioned some of those. One of the challenges is that they're only targeting secondary pests. And that, by definition, means they're not targeting the primary pests that we're most worried about. Only 1 to 5% of the active ingredient that's coated on a seed actually goes inside the plant, and they're only providing protection for 2 to 3 weeks, when the growing season, is much, much longer. One of the biggest challenges is one of their benefits. That is that they're water soluble, so sufficient rain can wash them away, leading to groundwater pollution and persistence in kind of soil water. So they persist in the soil anywhere from 7 to 7,000 days based on the active ingredient and the soil type, which is a very long period of time. They also have these kind of untold non-target effects, some of which we're trying to quantify, but the full range of those non-target effects is unclear, and they can exacerbate some non-insect pest populations. I'll just go into one of those examples today. So neonics have been adopted in crops kind of quickly over time. Here's another figure that we produced for a publication a few years ago. The amount of neonics on the vertical axis kind of over time. And you can see their use in corn and soybean really took off in about 2004. That's when they started to be coated on seeds. Here's another view of those data from 2014 and kind of looking backwards. And the amount being deployed of neonics on seeds was kind of doubled between 2011 and 2014. That's largely because seed companies started coating higher rates of neonics on corn seeds. So they went from that 0.25 level to the 0.5 or 0.6 level. So that's 0.6 milligrams per seed. So there was this doubling that occurred nationwide in just that 4 years because of the amount coated on each seed was increased. Just as an aside, these data are no longer being collected. We gathered these data from the U.S. Department of Agriculture and the U.S. Geological Survey and compared to databases. But the USGS and the USDA and the EPA do not collect use information on neonics deployed as seed treatment. So we're kind of blind. So From 2015 onward, we have no idea how much is being deployed, but based on this adoption curve, there's no indication that the enthusiasm for seed coatings is tailing off. Perhaps you've seen these maps, but these maps are from the US Geological Survey, and you can go on their pesticide synthesis website and see these. But this is the amount of clothianidin that was used in 2003, which is to say none. And then that's 2011. That's being driven by corn. So this figure at the bottom shows the estimated use in millions of pounds over time and the different colors of the different crop species. So this is being used on corn, and it's difficult to get some untreated corn seed these days. So it's difficult in the United States to find a corn seed that doesn't have neonics on them. Right, so that's the heart of our country being lit up by enthusiasm for these products. And that's 2014, and I can go back and forth. So that's 2011. 2014, you can see it gets darker and the extent grows slightly. That darkening color is the amount on the seed kind of going up over that time frame that I just described. So that's the amount of clothianidin. It's being used very widely on different crops, but it's being driven by corn. If you think about corn and soybeans, what can we control using these neonic seed treatments? Here's the list here on corn and then on soybeans. The insects that are underlined are where the insecticide can do pretty well. The ones that are in parentheses are where the insecticide does particularly poorly. So the list isn't very long, and the list of ones that it's controlling well isn't that long either. And again, those are secondary pests. So they're not the primary things we concern about, like European corn borer or Western corn rootworm, which are major pests of corn. In my hands in central Pennsylvania, this is the yield benefit that we see, which is to say none. So this is yield on the vertical axis in both figures, where we have an untreated seed or a insecticide coated on the seed in red, both in soy and in corn, and we see no benefit. That's because the insect pests are relatively rare. Again, they're secondary pests. It's not because the insecticide doesn't kill insects, it does. It's that the insect pests are rare. Layering on top of the rarity of the insect pests, note how quickly the compounds actually leave the plant. These data, again, are from a colleague at Purdue University. The vertical axis shows the amount of clothianidin in a plant over time, but the time is really days after planting. So if the corn plants were established on day 0, this is 10 days after planting, 20 and 30 and so on. And these scientists quantified the amount of clothianidin in those corn plants that they picked various days after planting. And you can see somewhere here around 6 or 7 days after planting, the titers in the plant are pretty high. So this would be a young corn plant, just a few inches tall. But by day 10, the levels in the plant are seriously low. And by day 20, they're almost non-detectable. So they're almost at 0 here. So that just emphasizes that the concentrations in the plant drop relatively quickly. So by day 12, 13, or 14, it's difficult to detect these compounds in the plant. Right? So we're targeting pests that aren't very common with an insecticide that doesn't stay at concentrations inside a plant very long. So just to put a kind of a view on where these insecticides are going, if we coat these things on corn seeds, we lose some of the insecticide to dust as planting, what's called refuge dust or kind of expelled dust. We also have some that are taken up by plants. So the corn plants, of course, are taking some up, but that's only about 2 to 3%. The great majority of it, 90% or more, is staying in the environment where it can leach into waterways. It can go into nearby kind of grasslands or forests where it'll be taken up by those plants because, again, it's a water-soluble insecticide. Remember, though, that we're getting very little protection against these root-feeding pests that we're targeting, a maximum of 2 to 3 weeks. And that's only benefiting 5 to 8% of the cornfields. And those data are based on nice work done in both Quebec and in Ontario. So the insecticide isn't really going where it needs to go to be beneficial to the crop. It's going on all these other places, causing challenges. From data that we've collected here in Pennsylvania, we can kind of confirm that it is leaving crop fields. So we've done a 2-year experiment using lysimeter plots. And a lysimeter plot is simply a way to collect water in the field and know where it's kind of come from. So we established corn plants on a slope that had lysimeters, and lysimeters allow you to collect either surface water or subsurface flow and kind of quantify the amount of water there. And then we sampled that water occasionally and detected and screened it for insecticides. So these three figures simply show surface runoff in the left-hand column or subsurface runoff in the right-hand column. And the top figure just shows the amount of water that's moving. So that more or less reflects different rain events. And the bottom reflects different amounts of thimethoxam in the green and then clothianidin in the purple. We coated these corn seeds with clothianidin. Sorry, take that back. We coated these corn seeds with thimethoxam, but the first metabolite of thimethoxam is clothianidin. So we actually have two neonics in the system. And you can see that thimethoxam is detected shortly after planting with a pulse kind of mid-season. So this is actually October in the surface runoff, and the subsurface flow shows a similar pattern. So most of the thimethoxam kind of leaches out of the system quickly, but clothianidin kind of sticks around longer. It's a little bit less water soluble. So we're getting detections of clothianidin, particularly in the subsurface flow, well out into February after we planted in May. So this is February, March, way out here on the right. So it's still leaching from the fields, 9-10 months after planting. And this is, of course, problematic. I have my students have their own data on this, but I'll cite a well-established study in the literature. These data come from Iowa, and this figure just shows Iowa with different watersheds outlined in black. And these scientists from the U.S. Geological Survey tracked the amount of neonics in neighboring streams in these watersheds and related it to the amount of corn or soybean planting that had occurred. So the bottom figure shows on the vertical axis the amount of the crop that's been planted kind of over time. So let's just go to March to October. And you can see a corresponding peak of neonics in the water when you have corn or soybean planting kind of at its peak. So that means most of the crop is in the ground. Now when a rain event comes, it leaches the insecticide into the waterway. And what does this do? Well, this limits aquatic insect populations. Aquatic insects are at the base of most food webs, and that can have kind of knock-on effects. I'll highlight some work from the Netherlands. As you may know, the Netherlands is a waterlogged country. So these scientists from the Netherlands sampled water across their country, and this map shows in darker colors where neonic concentrations were the highest in their water. This is mostly surface water, so blue and white is relatively low concentrations, red and yellow is much higher. And these guys correlated the amount of neonics in their water to bird populations. So this figure on the bottom shows the mean species trend, which just shows whether or not a population is growing or not. So a negative slope will indicate that a population is not growing. Indeed, it is declining. And they relate the mean species trend to the amount of imidacloprid in their water, and the surface water, right? So this overall negative species trend shows that bird populations in the Netherlands are negatively correlated with the amount of imidacloprid in their water. And if you break it out across 15 species of insectivorous birds, you can see mostly that there is a negative concentration for each one individually. So this is a correlation, all right? It's not causative, but it's suggestive that neonics are not helping bird populations. That's the Netherlands. Let's think about the United States. Some researchers at the University of Illinois related neonics to bird decline in the United States, and that's this paper here. And they have some alarming figures in their papers where they're showing the amount of decline. So here, the red is the percent change from 2008 to 2014, with this darkest red being over a 50% decline in bird populations in those counties. Okay, so you can see it's darkest in the Midwest, and we have grassland birds, we have insectivorous birds, we have non-grassland birds, and we have non-insectivorous birds. So even non-insectivorous birds are not immune from this challenge. But the strongest effect seems to be on grassland birds that are insectivorous. Look at all the red in the Midwest here. If you look up at Connecticut, you just have orange colors, which say 0 to 5%, and that's a good thing. Connecticut doesn't have as much agriculture, and certainly not as much seed coatings that are being used in your part of the world. So that's nice to be outside the fray a bit. So this is a direct relationship between neonics and birds. These folks used a statistical approach that allowed them to conclude a causation, not just correlation, in the influence of neonics on birds. So let me then switch gears here and talk about some of the research we've done in Pennsylvania. And just as a background, let me just say that Pennsylvania is a no-till state. The great majority of our field crops are not tilled, so that is, they never see a plow. So our typical no-till field has residue like you see between the rows of this soybean field. So not tilling the field kind of decreases the amount of times we need to walk, to drive across the field. It conserves water resources, conserves soil resources, but it also leaves fields vulnerable to slugs. So Pennsylvania is a sluggy state, and we get a lot of slugs. So I have an extension appointment. I'm an extension specialist, and the pest species that I get called about the most in Pennsylvania field crops are slugs. So here are slugs on the front of a hay mower. I trust you'll never see this in Connecticut until you go all no-till, but this hay mower is just blanketed in slugs, a nice sheen of slugs. And you'll remember from biology that slugs are not insects, right? Slugs are mollusks. So they're in a whole different phylum. So you shouldn't expect a slug to be killed by an insecticide any more than you expect an insect to be killed by a molluscicide. All right, so just kind of keep that in mind. We call that foreshadowing when I went to school. And slugs, just for a little more background, eat whatever they want. If you're growing peas or spinach in a backyard garden, you're probably familiar with slugs in real wet years. But in Pennsylvania, where we don't till, they feed on canola, they feed on soybeans, they feed on alfalfa and small grains, and they'll feed on corn. So they feed on pretty much all our field crops. And they can do a heck of a job. So here's the soybean field from Lancaster County, southeastern Pennsylvania, after it's been replanted 3 times. So no farmer would be happy with this. Look at these large gaps in the stand. That's just an unacceptable soybean field as far as most farmers would go. And that's because of slugs. So slugs can feed on soybeans quite heavily. But in our research, we figured out that the more slugs, the more you use neonic seed treatments, the more slugs you get. So the vertical axis here is the number of slugs per trap. The trap slugs, we just put roofing shingles on the ground and we turn them over and we count the number of slugs over the corn growing season. And these data are from corn. The red line is where we had a neonic seed treatment on corn. The blue line is where we had an untreated seed. So on average over the growing season, you see we have more slugs where we're using this neonic seed treatment compared to where we aren't. And this difference between the blue line and the red line is attributable to natural enemies that like to eat the slugs, right? And I'll show you that in a soybean example. So from the very same year, the very same experiment, we did the same experiment in corn and soybeans. Here are the soybeans data. So when we had soybean plots with neonics coated on the seeds or not, we had far fewer predators, we had more slugs, and we had lower yield. So we had 31% fewer insect predators that like to eat slugs, mainly things like ground beetles or carabid beetles as they're sometimes called. We had 67% more slugs, and then 19% lower stand establishment and 5% lower yield in those plots where we're using the neonic seed treatments when slugs were our main concern. Okay, and that's emphasized by this figure, which shows the number of slugs on the vertical axis relative to predation. And this predation number is just an assessment of how much activity the predators are involved in. So how many things are they killing out in fields? So you can see as predation goes up, the amount of slugs in our traps comes down, but it differs based on the amount of neonics, or based on whether the presence or absence of neonics. So in the absence of neonics, these white dots, we're getting far more predation. So predators are killing far more slugs than where we're using the neonics. The neonics, we have fewer predators and less predation. All right, so in this case, the insecticide is disrupting what we call natural control or biological control. And that's because the insecticide is moving from the soybean plants into the slugs. So the slugs are feeding on treated soybean plants. They're not susceptible to the insecticide, but they get it. So this bottom figure shows the amount of clothianidin in soybean plants, and then the amount of slugs that we're feeding on those soybean plants. Okay, so in the untreated, which is not shown or is not detected, we don't have any neonics, and then there's none in the slugs. In the thimethoxam example, and again, because we're coating seeds with thimethoxam, we have thimethoxam and clothianidin in the system. One's the first metabolite of the other. Again, we have a lot of neonics in the slugs themselves. So when a beetle comes around to attack a slug, it actually gets poisoned because the insecticide then moves from the slug and can poison the beetles. And these amounts of insecticides are significant, so very little is needed to kill a honeybee, so less than 10 nanograms. And that's what we're showing here. So honeybees are killed at much lower amounts than we're detecting within slugs. And a related beetle species is killed by about the same amount as what we're finding in slugs, but we're having twice as much because we have about 100 parts per billion of thimethoxam and 100 parts per billion of clothianidin. So we have twice as much that's necessary to kill a beetle. Okay, so that just kind of establishes that there are these non-target effects. So neonics are causing some problems. Let's use something else. And this is certainly an option, but all insecticides have downsides. A better approach would be to figure out what needs to be controlled and control it if necessary. And that's where integrated pest management comes in. Dr. Robert alluded to this, and it's just using a combination of tactics to control pest populations, right? So we're going to scout for pests, use insecticides if necessary, particularly if that population exceeds what's called an economic threshold. This way, by just metering out our insecticides necessary, we can maintain natural enemy populations to assist with pest control. Another neat detail about integrated pest management is that it considers economics. So we're only going to treat some damage when the value of that damage equals the cost of the treatment. And just a quick example, so if you're losing about $5 per acre, but it costs $10 per acre to treat a field, then you shouldn't do anything. It makes no economic sense to treat that field. But if you're losing $10 an acre, and it costs $10 an acre to treat, then you deploy an insecticide. That's just kind of a way that IPM helps you decide whether an insecticide has any value. So neonic seed treatments are being used regardless of need. They're being used outside of IPM. From that work from Canada, they're only benefiting economically 5 to 8% of the fields where they're being deployed. They have this negative influence on beneficial insects, innocuous insects, and that includes natural enemies, pollinators, and decomposers. And no one's really talked about the resistance potential, but insect populations are developing resistance to these compounds kind of every year. And that's evident in the southern United States, not as much in the northern United States. So my advice to farmer when I'm on the extension trail doing my extension service is that manage for the pests that you have. If your main pests are slugs, the insecticides aren't helping you at all. Actually, they're making the populations worse. But in fact, if you use IPM, you probably don't need as many insecticides anyway, because the natural enemies will do your job. So I encourage them to use IPM, assess their local populations, and figure out if they need a management population. And just to acknowledge what Mr. Robert said, that we're starting to, we've studied planting green for a while now, so planting a cash crop into a standing green cover, and it works really well, and it helps maintain natural enemy populations, helps control slug populations. So we have many farmers in Pennsylvania that are now adopting this approach. So this is what their field looks like after they plant corn or soybeans. Because they have a slug problem, this is their approach. And it can be awfully pretty. We have other farmers that are planting into crimson clover. So you can call this planting pink. So a small number of farmers are doing this, but the number is increasing and more people are curious about it. But the only way this works, if this approach to planting is combined with IPM, because that allowed the natural enemy populations to persist and allow the natural enemy populations to contribute to insect control, whether it's slugs or insect pests. All right, so that's my time. I'll just have a few conclusions and I'll wrap up and take some questions. So seed treatments can provide some value when the pests are around. The problem is the pests aren't around very often. Most seed treatments are being used as insurance. They're being used against pests that are uncommon. These are water-soluble insecticides that pose a challenge because they don't stay in a field. As soon as it rains, they kind of move out. They're very mobile. They can contaminate adjacent habitats, and they have a lot of unclear consequences of what they're doing in the environment. They certainly limit ecological interactions from our research. They're changing insect abundance and diversity, and they're allowing pests to be more successful, particularly slugs. But my approach is to try to use neonics via IPM, because they'd be far more effective and less damaging, and there'd be far less on the landscape. All right, I think I ran through that pretty quickly, but I'm happy to take any questions of you guys in the room there or folks online.
Great, thank you, Professor Tripper. It's always shocking when you hear that something that's being used so freely, actually, if it was a little bit more controlled, it would be a lot more effective. We do have some questions. Someone asked, is Advantage used on cats and dogs to kill ticks?
It might be marketed against ticks, but I don't think it'd be very effective against ticks because, again, neonics aren't very good against arachnids. But I'm not a veterinary entomologist. I don't really know that. That's kind of an educated guess.
Someone asked if I buy seeds from any store, am I getting included seeds?
Well, that's a good question. So if we're talking about large acreage crops, if you're buying corn, without question. If you're buying seeds for your backyard garden, that's typically not standard, but depending on the seed company, it may be standard. So I would encourage you to ask and find out. My family are enthusiastic buyers from Johnny Seeds, and I'm not advertising anything about Johnny Seeds, but my understanding is Johnny Seeds doesn't use any neonics on their seeds.
Thank you. I know that if you buy plants, you check the labeling from Walmart or from Home Depot, because pollinator plants will often have been treated with neonicotinoids, so you're actually doing the reverse of what you think you're trying to do. But they do usually state that there is that they are treated seeds that the plant came from. Why was the amount of neonic doubled in seeds in around 2011? Was it for resistance?
Doesn't seem to be for resistance. It seems that companies made a choice to increase the rate. I haven't gotten a straight answer from large seed companies on why that was done. A cynical person might think it was for profit, but I don't know.
Why did they stop collecting usage data? And is that just for neonics?
This is a kind of more complicated issue, and I'm not going to go into all the details just for time. But the data on seed treatment are pretty unclear, and that's because lots of farmers don't know they're using them. So there's a paper that came out in 2000 or 2001 that showed that about 40% of corn and soybean farmers don't know that the neonics are on their seed. So then if you ask a farmer whether they're using a neonic or not, then their answer may be uninformed. And it's no fault of their own, but it's just an engagement issue. So if you have to spray an insecticide across a field, you have to go into the shed, you have to pick up that jug, you have to put it in the sprayer, you have to know the concentration, and you have to know the kind of limitations of using it. So you need to be more engaged in the process. If you're just planting a coated seed, all you gotta do is plant the coated seed. You don't need to know anything about what's on it. So it's an engagement issue. And apparently the survey company that was asking the questions of farmers to find out how much insecticides are being used in the country became less and less confident that farmers knew with confidence what their answers were, whether they're correct or not. I'm kind of screwing this up, but you know what I mean.
So someone asked if you could repeat the title of the paper showing bird decline in the US, and if you could just share that with us, we'll be sure to share that with all of our participants.
Yes. Do you want me to share a screen and show it again, or what do you want me to do there?
If you pop the screen up and then just email the organizers, we'll make sure that we include it in an email out to all participants too.
All right, let me just make a note of that. But you want me to also share the screen and show it?
Yes.
Oh, okay. You got it.
Thank you.
Sure. What's this? All right, this is a bit tedious. Oh. There's the paper right there.
There you go. Okay.
I can make a note to send that to Louise, I guess, right?
Perfect. Send it to Louise and we will get it out to all participants. There was a comment, isn't it difficult for farmers to buy non-treated seeds?
Yes. I'm going to stop this so I can see you guys. Yes, particularly for corn. Soybeans, again, this is a little bit unclear, but based on our research, it seems that about 50% of the soybeans planted in the US don't have a neonic on the seed. But with corn, it's almost 100%. And if you ignore the amount of organic corn, which is trivial, our estimate is that it's about 100% of the corn seed in this country is being coated with a neonicotinoid. So it's very difficult. And if you're a farmer and you want to get untreated corn seed, you need to order super early, and you need to be kind of in your seed seller's ear. And I guess I should say that that's the case if you're buying from some of these national companies. In Pennsylvania, we found that local companies are far more willing and able to provide uncoated seeds, untreated seeds, and have more flexibility in their inventory. So if you're a farmer, you know farmers that are looking for some of this stuff, I would say go local.
What advice do you have for those of us trying to educate our legislators about the harms of coated seeds? And are there advances happening in Pennsylvania on this?
What was the first part of the question?
What advice do you have for those of us trying to educate our legislators about the harms of coated seeds?
Well, it's that they're largely unnecessary. I mean, they're necessary. Let me revise that. The more intensive production you're using, the more likely they are to be providing a benefit. So if you're growing continuous corn, that's where insect pests are most challenging. If you're growing continuous corn in Connecticut, you could well be facing a pest like Western corn rootworm. If you're growing a corn and you're worried about Western corn rootworm, you cannot buy uncoated corn seed because you are going to use, say, BTC, a transgenic type of corn hybrid, to tackle that problem. But those transgenic seeds come with the insecticide coated on them. So if I was to be talking to a legislator about all this, it's that the seed market is very complex and there's very little choice. Farmers are being forced to use these pest control packages that kind of include the transgenic traits, whether that's for the insecticide or herbicide tolerance. And then the insecticides and fungicides are being coated on there. And it just becomes a pest management package, and the grower doesn't have much option. They either go with that or they go totally a total conventional seed, which doesn't have the transgenics, doesn't have the pesticide coated on the seed. In our research, those untreated seeds are great. They cost less. They yield just as well. The pests aren't as abundant. We're promoting predator populations the best we can, so those crops are well protected. And if we need to respond, then we have an insecticide in our back pocket that we can spray. It won't be a neonic; it'd probably be a pyrethroid. But we're trying not to leave the fields vulnerable. So nice thing about IPM is it provides this nice intermediate stage. It's like a Goldilocks approach, right? We're trying to use it where it's necessary rather than not at all and everywhere. So talking to the legislature, I would advocate for IPM, and these seed treatments as they're being deployed across the country are certainly not within IPM, despite what industry representatives might say. They're just not right on that front.
And then the second part, and we have a few questions on this, is what's happening in Pennsylvania? Are retail sales of neonics prohibited? Are they limiting sale of corn?
Nope. So we have no legislation in place like they have in Quebec and other like European Union countries. Pennsylvania's seed treatments are popular. They're less popular among a certain type of farmer, a farmer that's more interested in soil quality. They're members of this soil health movement, but it's difficult. So I've talked to many farmers and they can't get the untreated seed. So what they'll often do is they'll go untreated soybean, but they'll go treated corn because to get the genetics or the hybrids they want, they need that seed coating. The real stubborn farmers that are willing to be a pain in the neck of their seed provider will find the untreated seed. They might be ordering that seed in, say, August or September, but you need to be fairly headstrong to go that route. And those folks are here in Pennsylvania, but I'd say they're in the minority because, as Mr. Robert said, the industry is coming up your lane. If you're a farmer, they're coming up your lane many times a month. And they're going to use some peer pressure on you to say, everybody else is using these treated seeds. Why wouldn't you? It's just, it makes things a little bit easier. And there's a lot of pressure to use them, in part because industry is making a lot of money on these things. I mean, this is a profit point for companies. They're never going to say that. They always say that it's for the farmer's best interest. But behind that is that they're making fair profit off of these insecticides they're deploying on seeds.
Well, we've got a couple of we got a few more questions and I'm trying to consolidate these. We have a couple of people who asked about the 2-week time frame for it being shown in prevalent in seedlings. They both asked about it being in pollen. Like, is it present in the pollen beyond the 2-week period?
Yes, so those concentrations in corn plants I was referring to are kind of yeah, so they ground up the entire corn plant and then it's difficult to detect. But they're still small amounts, and apparently other research has shown that those small amounts can be incorporated into pollen. So it's in the plant, it's just not at titers high enough to control any pests. It's kind of in this background concentration, and it does get incorporated into the pollen. What's unclear to me is how damaging those small concentrations are. I would imagine that if honeybees, for example, are collecting corn pollen, if they collect enough of it, it can be problematic. And there's certainly papers on that, but not being a pollinator person, I haven't really delved into that world very often. But yes, it's still there. It's just in very low concentrations.
Thank you. In Connecticut, neonicotinoids are the major use of it is on lawns and golf courses for bug control. Could you address the usage, effectiveness, and unforeseen impacts, and perhaps alternatives that could be used?
Yeah, kind of not really. So my realm of expertise is in field crops, and I have a passing knowledge of insect control and kind of turf situations. But kind of nationwide use data bear out that the great majority of neonics are being used as seed coatings. The amount being used on golf courses and in commercial lawns is not insignificant, I'm sure, but it doesn't hold a candle to the amount being used on a nationwide basis. Because kind of corn, soybean production in Connecticut is relatively small, it may be that those residential uses are in the same realm as the amount being deployed on field crops. I don't know that. And I don't know the alternatives. Penn State being a large university, we have turf entomologists that could field that question better. And I'm sorry, I'm just not qualified to answer.
Fine, thank you. Would diamides be the replacement if neonic seeds were banned?
Yeah, that would be the way they would go, just as they've gone in Canada. And unfortunately, diamides haven't been around as long as they haven't been scrutinized as much as neonics have. Diamides are water soluble. They're less water soluble than neonics. I don't have a kind of a comparison I can give you, like how much less soluble they are. But as Mr. Robert's data show, they're getting into water just like the neonics are. Large companies have told me that they don't think the diamides are as toxic to ground beetles and other things that want to eat slugs as the neonics are. I've seen no data on that front, so I have no idea if they're right or if they're wrong.
And someone asked if there was a way to wash off the seeds and dispose of the contaminated water properly.
I would encourage you to buy the untreated seeds first. I would think it would take a heck of an effort involving various solvents to get the neonics or the fungicides off the seeds. A few years ago, maybe you guys remember there was this incident in Oregon where there was a big bee kill. No, take it back. That was in Germany, where there was a big bee kill because there was some problem with adherence of the neonics to the seeds. And it kind of got dusted all over this area of southern Germany. Since then, large companies have put a lot of effort into making sure the insecticide and fungicides are better adhered to the seed. Based on their kind of renewed effort to get stuff attached to seeds, I would think you'd need things like acetone and dichloromethane and xylene and all kinds of nasty stuff to get it off the seed. So I would encourage you not to do that.
Does not sound fun. Thank you, Professor Tooker. We're at 2 o'clock and we really appreciate you taking the time to speak with us.
Sure, my pleasure chatting with you. If you guys have further questions, I can be easily contacted up here at Penn State.
I'd like to invite, we have one more presentation and then we'll be taking a little bit of a break for everybody. I'd like to invite Hardy Kern from the American Bird Conservancy to begin to present. Mr. Kern is Director of Government Relations for Pesticides and Birds Campaign at the American Bird Conservancy. An international nonprofit dedicated to conserving birds and their habitats across the Americas. He holds a bachelor's in science and zoology from the Ohio State University and a master of public administration from Kent State University. At ABC, Mr. Kern focuses on legislative and policy solutions for environmental contamination concerns that impact birds and their habitats. He works at both the federal and state level to build a bridge between stakeholders, legislators, and regulators on Pesticides, Lead, and Endangered Species Act. And I was pleased to join in Washington, D.C. last week as we discussed pesticides with our legislators. Thank you, Hardy.
Thank you, Drew. Good to see you. I know, once in 2 weeks. This is great. I love it. Thank you, everyone. Good, what are we in? Good afternoon. Thank you so much for taking time on a Monday to come out and talk about this super uplifting, happy topic, right? This is the way that we all want to start our weeks. I have to say, I've been in the pesticide policy world for a little over 2 years at this point. I have the great privilege of working for American Bird Conservancy. Pesticides and environmental contamination are my 24/7 job right now, which I absolutely adore. And the lineup that Connecticut Audubon has been able to put together. This is the Oscar Best Picture nominee list of pesticide professionals. So thank you so much to Connecticut Audubon. Let's give them a hand for putting this together. Coalition for Pesticide Reform is what I mean. So thank you. So today we're going to continue on with the super fun stuff. My presentation is, do I have a way to advance? Is that this? Thank you. Neonics and birds, a match made in hell. I gave Tom Anderson a few different options of what we could call my presentation. And when I checked the final program, I was thrilled to see that we went with this one because it really paints a picture. So a little bit very quickly about American Bird Conservancy. If you haven't heard of us, we are dedicated to conserving birds and their habitats across the Americas. And on the left there, or your right, I should say, the right there, you can see our pyramid that we use to address different threats to birds and promulgate bird conservation. The red bit at the top is focusing on endangered birds, so birds that are highly imperiled. We then have birds of conservation concern. Those that are on their way, perhaps to endangerment. Threats to all birds, that's kind of where I fit in. And then down at the bottom is building out conservation capacity. So we work across North and South America. The vast majority of my colleagues are field biologists. We have a very small but feisty, loud and angry policy team that I'm very lucky to be a part of. So I'm sure we've all seen this map. I'm a huge birder myself. This is a map of the North American migration flyways. These are the highways that birds use when they are going north to south, south to north, going from their winter quarters up to breeding across the United States and Canada. And this map, and here's where we are, we're over in one of the most heavily used ones, the Atlantic Flyway. This map is highly representative of why pesticides are such an enormous threat to birds, and also why it's really, really hard to reduce threats to birds from pesticides without taking a bunch of different steps all at the same time. When agencies like the Environmental Protection Agency, which is responsible for labeling and doing most of the pesticide regulation in the United States, when they look at a species and try to determine how to best protect them, they like putting things in distinct boxes and buckets. They like to know this species is going to occur exactly here. It eats exactly this. Therefore, we can calculate its risk in exactly this way. When you have birds that have highly fluctuating ranges like they do during migration, did I hit something? I think I did. My apologies. There we go. Okay, great. But when you have species like birds, this is the birdcast, the migration forecast from 3 nights ago, the night of March 8th. You can see we're already starting to get some early spring migrants. So there are some species starting to come south to north. this is what peak migration can look like. This is 557 million birds in flight in August of last year, or in August of 2 years ago, I should say. These are the different concentrations of species that we might see moving around. And where are they going? As we saw in the paper that Professor Tucker referred to, right over the Corn Belt, right over the breadbasket, right over some of the most productive soybean areas in the United States. But as we talked about today, and as you'll keep hearing, neonics are used in a lot of different ways. And all of this is happening against the backdrop of an historic decline in bird species across North America. This paper was published 5 years ago, 2019, and it documented that we have lost 3 billion birds since 1970. That's not saying there's 3 billion fewer this year than last year, and after they breed, it'll come back. That's 3 billion below baseline. There are, of course, a lot of different factors that play into this, but pesticide use has been repeatedly identified as one of the biggest threats to birds. Last year, towards the end of the year, Stanislaus Reigal in Europe did a giant study. They looked at 50 years worth of breeding bird data in Europe across almost 400 species. And the number one threat, the number one factor that contributed to bird declines in Europe was agricultural intensification, with a particular focus on pesticide and fertilizer use. We know that this is something that's happening that we need to be aware of. And so what does this look like in our backyards and in some of our favorite species? We're looking at about 1 in 4 birds gone since 1970. And the two larger groups, I should say, that have been hit particularly hard are grassland birds. We're seeing about a 53% decline in birds that live in grassland habitats, which is, of course, also where we grow a lot of those large monocultures. And aerial insectivores. Things like swifts and swallows and larkspurs and larks and all sorts of different birds along those lines that fly around and grab bugs out of the sky. 2 in 5 barn swallows lost since 1970, and we are seeing this in other groups of birds as well. There is an ongoing question, though, of are we really experiencing a decline in insects in the United States? Is that tied into the decline of other species? And there's tons and tons of papers that say absolutely that's the case. But I have been in rooms with the head administrator of the EPA's Office of Pesticide Programs, and they said, can we even definitively say that there's a decline in insects? And if that is the case, is that tied to birds? Can we even make that leap? Yeah, we can, you know. So there was a paper done by Doug Tallamy and his colleague, I believe it's Gregory Schreiber. I might be getting Mr. Schreiber's first name incorrect. But they looked at different species of birds, about 306 different species of birds altogether. And then they looked at the diets of those birds and compared them to where they saw declines and where they saw increases. Not all groups of birds are in decline. And this is what they found, because I'll go into it in a second. Real quick guessing game. Anyone want to guess what percent of all terrestrial birds eat insects? Just shout out a number. What percentage? 96, 90, yeah. 96. I forgot who I'm talking to. Normally people are like 20, 30. I put out a bird feeder, so none. Yeah, 96% of species, right? Eat insects at least some point throughout the year, typically when they are rearing chicks. So Mr. Tallamy and Mr. Schreiber, this is what they looked at. The species where insects were not essential, some marsh birds, some shorebirds, some raptors that are purely carnivorous but not insectivorous, they are seeing some population increases. But for the birds that are insect dependent, these are the ones that are in decline. These are the ones that we are seeing a marked decrease in the number of individuals in those species throughout the years. So here's another question for you, and I think we'll do pretty well. How many caterpillars will a single Carolina chickadee feed its nestlings before they fledge? So we're talking about one tiny little chickadee, and we're talking about one clutch of eggs. This is not a larger bird. I heard 6,000. Anyone else have guesses? No. Yeah, see, y'all are good at this. It is 6,000 to 9,000 caterpillars. This is a good group you put together, Joyce. Well done, yeah. So this is pretty astonishing to most people. 6,000 to 9,000 caterpillars for one pair of chickadees to raise one clutch of nestlings in a single season. Chickadees can have up to 3 to 5, in some cases, clutches per season. Chickadees are little, so you can imagine larger species of birds, multiple nestlings, a reduction in insects is going to hit them pretty hard. And in a study that was done, they did find that lower caterpillar biomass led to all sorts of other negative externalities. We had more frequent nestling mortality from starvation. Fewer of them actually made it to fledgling capacity. The ones that did make it out of the nest tended to be a little bit lighter. So we're not just talking about when there's less insects, they're going to turn to other things and be fine. We are seeing some real world ongoing impacts. So now this gets to the fun stuff, neonics and birds. And I put together this timeline. It's not exactly spaced to scale, so forgive me a little bit. And what you'll also notice from a lot of the presenters today is we're using a lot of the same facts and figures and sometimes even the same graphs. And that's because the science is there, it's sound, and you can see across disciplines we use it. Professors, health professionals. I'm a flippin' work from home bird lobbyist and I'm using it. You know, this is really interdisciplinary. So in 1992, imidacloprid, the first neonic, was registered in the US, but as Professor Tucker showed us, didn't really take off too well. And then in 2004, after it had been there for about 12 years, its use really began to increase. There's a bunch of different reasons for that. There were some other really harmful compounds that were in wide use that we started to notice were killing a lot of things like carbamates and organophosphates. And so we needed alternatives to those. In 2011, as Professor Tucker walked us through, the neonic use doubled from the previous year. And then in 2013, American Bird Conservancy and my predecessor, Cynthia Palmer, along with Dr. Pierre Minot, who is one of the most accomplished and best ecotoxicologists in the world, put together this report entitled The Impact of the Nation's Most Widely Used Insecticides on Birds. It had everything in there from policy recommendations, syntheses of different studies, graphs, charts, recommendations for how the EPA could do better by birds. That was 11 years ago now. 2015, and I'll have a better picture of this. The US Geological Survey stopped tracking the use of pesticide-coated seeds, so mostly neonics, for that inconsistency that Professor Tucker was talking about. So in 2023, we got a little fed up at ABC. We decided to publish another report, and we went with a little punchier title called Neonicotinoid Insecticides, Failing to Come to Grips with a Predictable Environmental Disaster. It is almost 200 pages long. It has been cited already about 300 times in different scientific studies. We use it in our state level and federal advocacy, and it really hits on what's happened in the decade from our first report. The other thing that's happening is right now, the EPA and several other large regulatory agencies are starting to look at the impacts of neonics on some species. They're starting to slowly introduce some reforms and some comment periods. And that's mostly because they have been sued repeatedly under the Administrative Procedure Act and the Endangered Species Act. And so they're complying with litigation deadlines. So when you talk about the impacts of neonics on birds, there's 3 different ways that we're really seeing them exposed. The first is through ingestion, either ingesting insects that have been sprayed with them or ingesting seeds that have been coated. The second way is direct interaction, which might be being sprayed accidentally, so getting it on their feathers or on their skin. And then there's also these interactive uses. So we talked about them being systemic, they're grown into a plant. That means every single tissue in that plant is going to have neonic in it in some way or another. Maybe it's not at high concentrations, maybe it's metabolites, but it still has the potential to expose birds to it. Pollen, fruit, nectar. There was a few studies done in Canada where hummingbirds started to show up with neonics in their bodies when they were actually allied in their cloacal fluid when they were captured in the wild. And their best guess is that they were feeding on nearby blueberry bushes that had been topically sprayed with neonics, as well as grown from neonic coated seeds. So those are the three different routes. And then when we're talking about what does it look like when a bird is directly exposed to these systemic insecticides, this is a little upsetting, so I apologize, but I don't want to pull any punches. These are two live birds. I'm going to see if will this make me do an external link? Okay, great. So this is a young female cardinal that has been exposed to what was later identified as a spray version of imidacloprid. This is what it looks like. It does exactly what it does to insects in birds when they are exposed to high quantities. So you can see she's still alive, but she doesn't really have motor control. And then there's also a blue-gray gnatcatcher who shows much the same signs. This is what it looks like when birds are accidentally exposed to these chemicals. And both of these were tied to a neighborhood, so lawn applications of it. This was not agricultural applications. So these were two birds that came into a wildlife rehab center. And I thank so much Raptor Education Group in Wisconsin for letting us show this. I'm getting it. All right. And then in other species, which are, whoops, I'm so sorry. Yeah, absolutely. Thank you. Oh, there it is. Perfect. Oh, good. So this is in a carnivorous raptor. This is a American kestrel. So we're not seeing as much of the flopping around, lack of motor control, but you can see it's trying to eat. And this is a bird that normally has to be able to catch grasshoppers, that has to be able to catch mice and voles in very quick settings, and it can barely eat meat when it is put right in front of its face. All three of these birds did end up making a recovery. None of them were able to be released back to the wild, though. So they lived out, the two songbirds lived out their days at the center, and then the kestrel is now an education bird. So sorry to bring you down there, but like I said, I don't want to pull any punches with, is that me? I think I lost it. Okay. We'll get me back. That'll be great. Oh yeah, we're just scrolling down. So that's what it looks like though when these birds are exposed to these chemical compounds. It is a loss of motor control. And the reason why I wanted to show that is because when the EPA or other bodies evaluate these chemicals, they do them in laboratory settings. They largely do them with quail or with mallard ducks that have been raised for laboratory testing. And what they're looking for are LD50s, which is the lethal dose that it would take to kill 50% of organisms in a particular group. So what they're looking for is how much does it take to actually kill the organism? We're not examining what the sublethal effects look like. We're not examining what it looks like when a bird is alive, but it's not able to feed. And if it's flopping around on the ground, they could be very easily preyed upon. They might not be able to feed themselves. If it's a female or a pair bonded group, or rather a species where both the male and the female take care of the chicks, are they going to be able to raise a brood successfully? Those are the questions that are not being asked. And in case anyone was wondering, you know who runs all the toxicity tests that the EPA evaluates? The pesticide registration companies. That's right. They are the ones that submit all the data that is used to evaluate how lethal a chemical is and how it should be mitigated. That's obviously very problematic for a lot of reasons. And we can talk endlessly about that, maybe on our 15-minute break for sure. So there have been some studies that have been done on wild birds that were caught and brought into laboratory settings. Margaret Ang, Bridget Stutchbury, and Christy Morrissey did one of the most incredible ones, I think. This was on white-crowned sparrows. They exposed them to both imidacloprid and chlorpyrifos. They captured wild birds, so these were not lab-raised birds. So we know that they were exposed to normal natural processes. And they brought them in and exposed them using an oil matrix to 3 different treatments, different concentrations of imidacloprid and chlorpyrifos, as well as a control condition where they were just injected with a neutral oil or I think with saline was the other thing. So this is looking at, thank you, effects on body weight and movement. So What's really interesting here is we were talking about birds. Birds need to migrate. A bird can only migrate if it's able to pack on a little bit of fat and move around, right? We know that they need those extra calories to be stored on their bodies. The birds that were exposed in laboratory settings, the control bird here, you can see its body weight remained fairly stable. The two that were exposed to the different concentrations of imidacloprid, or rather the groups that were, their body weight significantly decreased up to dose 3, and then 14 days post-dose, it finally got back up to a baseline. This is in a laboratory where they still had access to foods. They did not have pressure from outside predators, and they were studied closely for 14 days. This is not wild conditions. This is just a wild bird. And over here on the other side, you can see this is their basically their movement ability, the distances that they moved after they were exposed to these chemicals. So it goes way down, and it is statistically significant in the treated birds. So are you going to be able to hop away from a predator if you've been exposed but you haven't been killed? This is the one that I think is most interesting. It's a little hard to interpret, but they do these really cool migration studies. They were pioneered by German scientists. Is anyone here familiar with Zuganruhe? The need to migrate? Well, impress your next friends on a bird walk. Zuganruhe. That's when a bird's like, oh, I'm itching to go north. That's what we call it. And for a lot of birds, they can navigate either celestially by looking at the stars, or they can navigate using the Earth's magnetic fields. And the test that they do is they put them in these funnels and they put ink at the bottom, and then they can either manipulate the magnetic fields of the chamber, or they can put a fake night sky over top of the birds, or sometimes they just put them outside to use natural cues. And then they look at how the birds' little inked feet have gone up on a compass, basically, to see, are the birds at the time of year they should be going north? Are they going south? Are they doing what they should be doing? Up on the top row here, we have the control group. And then in the lower two here, you can see these blue dots become much less clustered and they get all over the place. The dots are the average direction that birds were hopping. And this little red arrow up here shows basically the intensity with which they were moving. This is really hard to interpret, and it took me like 9 read-throughs before I got it. But essentially what it's saying is that the birds in the control group were still hopping roughly the same way, pre-exposure and post-exposure, and then several days afterwards. They knew which way to go for migration. The birds in the different exposure groups, this is pre-exposure, so there's an average of them hopping in the same direction. Post-exposure, you can see them going all over the place. They literally lose their ability to navigate. So even if they're able to keep on food, even if they don't get, or keep on weight, even if they don't get caught by a predator, they might not be flying in the correct direction. And over here on the right, you can see we're not talking about a ton of food. We're not talking about huge amounts. This is the amount equivalent to 4 canola seeds, or less than 1 corn seed, or sorry, less than 10% of 1 corn seed, or in the high control group, 9 canola seeds or 0.2 corn seeds, not even a whole corn seed in these sparrows. So this is taken from the second report that Pierre and I did. You don't have to read the whole thing. But if you look at laboratory data on these different species, these are all species of birds that are used to test pesticides in labs to see how it affects them. It makes a lot of sense because it shows that for the smaller birds, going up to some of the larger bodied ones like mallard ducks, the quantile on this side, this is just used to say basically the risk from toxicity. So the bigger body the bird, the more pesticide it takes before they start to see that LD50, before they start to see toxicity endpoints. Well, that didn't sit great with Pierre because he said what you're not accounting for are smaller birds. Most birds in the United States are pretty little. They're migratory, they're passerines. They don't have the same body weight. They don't have the same flight patterns as, say, a Japanese quail or a rock dove. This is just what's easy to use in laboratory tests. And then they basically plug it into a formula and say, we're going to assume that a cardinal is 1/3 of a partridge, or we're going to say that a finch is 1/10 of a mallard duck. And that's how they scale their toxicity endpoints up and down. When you take the logarithms of both of these things, though, what we find using the same exact data used to plot this chart up here is that the less a bird weighs, the more toxic the same chemicals are. And what we know is that smaller birds are affected in a different way than their larger bodied cousins. So just because you have a dosing system, a risk system based off of something like a rock dove, doesn't mean that it's going to translate well into something small like a sparrow. We all following that? It's a little in the weeds. Cool. So neonic seed treatments, like we've talked about a lot today, I call them danger Skittles or evil Skittles. It's my other name. No offense to the Skittles Corporation. I love your candy, but that's what they look like. This chart on the bottom or on the right here, this is one of the most telling and interesting ones for me. So this chart's from 1994 when neonics were first used. On the top is the use of neonics. On the bottom is the use of other agricultural chemicals. And when neonics came on the market, their big thing was they're so toxic in such small amounts, you won't need to use other stuff. This is going to save you time, it's going to save you money, and you don't have to use as many other chemicals. What the real world data shows us is that instead of using neonics instead of other chemicals, they use them in addition to other chemicals, largely because of their use as seed treatments. And this is the next map that Professor Tooker was showing us. So this is clothianidin in 2014, that use. And then he said that the agency that collected the data, it got too hard to collect it on seeds. So they just stopped because it was too unsure. So this is actually perfect. He and I didn't even plan this. So this is 2014. Ready for 2015? It all goes away for the most part. It looks like in 1 year, we have next to stopped using clothianidin. The difference is we just stopped reporting where it's been used as a seed treatment. Because according to the federal law that governs pesticides, if you spray a chemical out of an airplane or out of a backpack, it's a pesticide. If you put it on a seed, it is not. It is now called a treated article, and it is legally exempt from the same statutes that regulate other chemicals. Is this fun? Is this great? Love it. Now to take this the next step, like I said, the EPA is really working hard to evaluate the impacts of a lot of neonics and a lot of other chemicals on endangered species especially, and in turn some other species while they're making those regulations. And when they were evaluating neonicotinoids for how they're impacting endangered species, of the 97 birds that are listed under the Endangered Species Act federally in the United States, there was only one bird that came back as currently being jeopardized by existing use of neonics. And it's this beautiful bird here, the Atwater's prairie chicken. They have very, very small populations. There's less than 400 birds right now in the US. They only live in 2 different places. And the reason why they were decided to be jeopardized by neonics was because there's a belief that the use of neonics leads to a decline in pollinators, which could then which would then lead to a decline in the available plants that these birds need to feed on. The trick is, Atwater's prairie chickens and a lot of other birds eat plants as well as seeds as well as insects. The EPA currently does not have a mechanism to account for insect loss and how that might threaten endangered species. And further, because of that weird loophole, it says right here, a limited amount of general usage data was available for some uses, e.g. developed in open space developed uses and seed treatments. This is their fancy schmancy way of saying, we didn't have the data to consider seed treatments, therefore we just decided not to. So we have formally responded and petitioned them to count 27 other species as jeopardized by neonics currently. So that's an ongoing effort that we have because of this lack of information. So moving on to, the other depressing part, but the fun stuff, the importance of insects to birds like we were talking about. So up until now, I've mostly been talking about the direct impacts of birds when they're exposed to neonics, but what happens when the bugs go away, right? Let's circle back to the beginning. And I want to give a huge shout out to our friends at the Xerxes Society for Invertebrate Conservation. My best buddy, Dr. Rosemary Malfi is here as well. We do a lot of work together at the state level. We comment on a lot of federal regulations together. And you should see the look on a lawmaker's face when you walk in and say, I'd like to talk to you about the birds and the bees. And, it's fun, right? So that same graph that Dr. Tucker showed us a few minutes ago in the Netherlands, they looked at a bunch of different bird species. There were notable declines in a little passerine called a corn bunting, and that's what started setting off some alarm bells. And what they found when they looked at all of these other different variables in this study, natural areas around the farms, urban areas, fallow lands, nitrogen rates, the one that was correlated, really the only one that was correlated with bird decline was the increased concentration of neonics. And when they dug a little bit more, they determined that it wasn't that the birds themselves were being exposed to the chemicals necessarily, it's that they were wiping out the insect populations. Fewer bugs, to put it very frankly, means less food for birds, which means less birds overall. And when folks have investigated this, there's three main additional causes that happen when there's less bugs in a given area. Number one, birds start to turn to less than optimal diets. Bugs are very, very nutritious. Lots of protein for a growing chick, lots of calories in there, really high quality food source to feed to your babies. However, when there's not enough bugs around, you might start to forage on some other things that aren't as nutritious, potentially insects that you wouldn't normally eat. You might overload on some seeds and some plants or leaves that you might not be as nutritionally developed to handle. There are even some reported cases of birds then going to farmlands and eating neonic-coated seeds because there's not enough bugs around. That's anecdotal, that hasn't been actually described in a scientific journal, I should say. The next thing is greater foraging distance. You have to go further away from your nest to feed your kids, to find food. During that, you might accidentally, or you might not be able to bring back as much during the day. So you might have one or two fewer babies survive that year. And then while you're out and about, and you have to travel further away from your nest, you might experience increased predation. That could either be from native predators like Cooper's hawks, reptiles, other large birds, or introduced predators such as domestic cats. If you want to talk more about domestic cats and birds, we have a gentleman who works at ABC who his entire job is just focusing on keeping cats indoors. We call him the most hated man in America. Grant Size. He does such incredible work, but man, the letters he receives, it's great. So I'm not going to go through all of this, but we do have some great resources available online, and I'll make sure I get them to the conference organizers here of the different impacts that neonics have on birds. So everything from life-threatening weight loss, loss of migratory ability, smaller populations due to insect loss. We have all the studies cited there. These are really nice handouts to have, things that you can give to your legislators. We just finished a new one that's specifically about seed treatments. And I also have a 2-page version of that 192-page report that Dr. Minot and I put together. So we'll make sure everybody does have access to that. And so what are we doing about it? This all is super depressing. It's really bad for birds, but what is actually happening? What are the next steps here? So back in 2017, American Bird Conservancy and a ton of our partners got together and we petitioned the Environmental Protection Agency to say, if you are saying that a seed that is coated with a pesticide is no longer a pesticide due to a loophole that was designed for lumber production and boat paint, we don't think that that should be correct. They sat on their hands until 2021 when they were sued and lost. And then in 2023, or 2022 rather, they finally responded to say that they are denying the petition because seed treatments are evaluated when the chemicals used as the coatings themselves are evaluated. That process happens once every 15 years, if you're lucky. So that's very, very infrequent. The EPA does not have to take into account new scientific data. Often they do, but their number one source is usually industry studies. And even further than that, they have opened up a new process that may change the way that they track the use of neonic-coated seeds by changing the language that's on the labels put on bags of pesticide-coated seed. They said that they want a system perhaps where growers would be made more aware of what is put on the seeds that they're buying, where there would be disposal guidelines, where they would track where the seeds are being used and in what quantities and what products. And also they want to make this much more accessible and easier to enforce for the EPA. So they want to do this all off a label that's now going to be, roughly the same length as the King James Bible. The other way to do every single thing that they want is to no longer exempt seeds from the Federal Insecticide, Fungicide, and Rodenticide Act. So it's kind of like saying we really want to know all of this stuff. We just don't want you to tell us all of this stuff. It's really, really bizarre. So it's a fun battle that we're fighting. So there's currently another lawsuit happening from the Center for Food Safety. We are submitting an amicus brief saying this is really bad for birds, essentially, and also identifying the ways that they've really poorly done their Endangered Species Act consultations. There are plenty of upcoming chances for engagement at the federal level. This is for everybody. There's this advance notice of proposed rulemaking on coated seeds. Pardon me. That's that labeling change, where there's going to be another round of comments on that. There's new regulations that specifically affect national wildlife refuges that anyone is welcome to comment on. And there's also biological opinions on neonicotinoids coming up. A biological opinion is what happens when the EPA says, we have a chemical, we want to register it under the Endangered Species Act. Here are the species that we think it might impact. Hey, Fish and Wildlife Service, hey, National Marine Fisheries Service, you're the experts on these species. What do you think? What do we need to do to make sure that these species are not impacted? There are roughly 1,000 active ingredients registered in the United States. There are roughly somewhere between 12 and 14,000 individual pesticide pesticide products that are registered. You know how many biological opinions have been completed?
No.
2. Yeah, as of 2 years ago, it was none, but now it's 2. They've done 2. So the EPA is really, really working hard. We are supporting their efforts, but basically they spent 40 years ignoring the law, and now we're wondering why everybody sued them. So it's just a lot of fun. But here's where I'm really hopeful, and here's why I'm so excited to talk to you all today. The states are really stepping up. State advocacy is an area where I've gotten a lot more involved. That's why I was so excited that Joyce and Connecticut Audubon extended this invitation to me. Why it's so great when we can bring them into Congress to talk about what's going on at home. There are 2 different bills at the Minnesota State House right now moving. Vermont has a fantastic program similar to Quebec's that they're trying to put into action. California has several bills up that we're working to promote as well. Connecticut has your great laws that are in the State House right now. And the state of Washington is moving towards a non-agricultural neonicotinoid ban. There are already 10 states that prohibit the use of neonics, non-agricultural neonic uses rather, unless you're a licensed professional. This is where it's really, really moving. And Joyce, I don't know what your experience was, but the answers you get from your legislators in Congress, when you talk to them about what's happening at the state level and why these issues matter, it's way more than what I get when I go in there. So we really appreciate these actions because this is where the change is really happening. And with that, support SB 190 in Connecticut. It needs a little bit of work, but we got some ideas. The fact that it's even on the table being discussed is already a monumental step. And just to talk about what the success can really look like, New York State last year finally passed and signed into law the Birds and Bees Protection Act. It's a funny name, but it worked out really well. It phases out the use of neonics on corn, soy, and wheat seeds by 2029. All non-ag uses are going to be phased out by 2027, and they do have some exemptions written in there. Asian citrus psyllid and emerald ash borer are 2 big problems that they face a lot in New York, that the Department of Environmental Conservation said, we might need every tool in our tool belt to fight them. That's understandable. There's exemptions written in. It also says that if you're a farmer and you can't get these untreated seeds and you've really tried, you can also have an exemption written in yourself. That's the way that this is going to happen. You know, it's these little steps, but New York became the first state in the country to do this. There was also a California fish and game regulation based on a petition. I know it seems like a lot of trumpeting about how great ABC is, and that's not how I want to come across. This only works because of our partnerships and because, unlike a lot of our opponents, you know, we rely on science and things that are empirically evaluated, but that's neither here nor there. So in 2017, we petitioned the California Fish and Game Commission to stop using neonics on the lands that it owns and operates. As of 2 weeks ago, that was finally written into state regulations. The state will no longer use neonics in any form on any of its state managed lands, which was great. I sat through a lot of commission hearings about that, and then our attorneys at Earth Justice really did all the heavy lifting there. And then here's my last little slide, my real uplift. This is the thing that gives me hope. This is why I think this isn't a lost cause, why I'm confident that because we have people that love birds, this is gonna get okay. This is a graph of breeding pairs versus years. Anyone know what species this is for?
Osprey.
Osprey, close to an osprey. Bald eagle, that's right. Yeah, this is our good friend, the bald eagle. This is the classic success story that everybody talks about getting a species delisted. And it certainly is, but the reason why it is, I think, is what's so exciting. Bald eagles were most imperiled by DDT, dichloro-diphenyl trichloroethane. You want to get really good at Scrabble? Start working on pesticide legislation. I gotta tell you, the words that you learn are just absolutely incredible. So once we finally realized all the negative impacts that DDT was having, people lobbied their state legislators, people talked to their congressional representatives, the federal agencies started reacting. The EPA was created largely in response to this effort. DDT was finally banned in 1972 or 73. I think it was 72 was finally banned. I should have done a more precise arrow. And then there was an ESA deal, or rather, I should say, listing of the bald eagle in 1974 is when that finally happened. They finally got endangered species protections. And you can see it still took a few years before the population started taking off. Globally, DDT was finally banned in 2000. And then the ESA delisting happened. They were taken off the endangered species list in 2007. This is a species that went from next to extinct because of pesticide use to being removed from the Endangered Species Act. We're now at the point where the battles that I'm fighting legislatively on eagles are because they're nesting too much on power lines. So people are getting mad about it. That's a great problem to have. There's too many eagles and people need to make rules about it. That's the kind of stuff I want to be working on. This is great. And it only happened because of people in rooms like this. It only happened because we noticed, we applied science, and we used that to inform our laws and policies. And because we didn't give up. So DDT was used almost everywhere. Now it's been banned globally. I hope neonics are next, and I'm certainly glad to be on all of your sides and have you on my team while we're fighting this. So I want you, and so do the eagles, and so do all the other birds, to go out and keep doing what you're doing, because it wouldn't happen without you. So thank you so much. I'm glad to take a few questions.
Thank you, Marty. Marty is certainly enthusiastic about this, and just for some context, he is a certified bird rehabilitator as well as a former zookeeper. So Marty has seen the impacts of this. We do have a couple of questions. We're on a tight timeline, so we're going to try and keep this to just a couple of minutes so that everybody gets a chance to use the restroom, get another drink of water, grab some more snacks.
I had the whole 200-page report pulled out if you want to go take it.
Yeah, we're gonna share that with everybody later on. We have a question that says, the argument legislators get from the golf course lobby, which we just saw, and you know that I reached out, on, is that it's not a state issue. Pesticide policy is the job of the experts at EPA. Why is this a state issue?
Great question. Yes. Why is this a state issue? It's a state issue because every state is different. Every state has different species, different weather patterns, different pests that operate on it, or that might be found there. And there are fantastic experts at the state level. There are other pesticide issues. I was just in a room with the National Golf Course Superintendents Association, whose argument to the EPA, USDA, Fish and Wildlife Service, and National Marine Fisheries Service was that federal laws governing golf course pesticide issues are too overbroad and need to be more localized. So my question back to them is, what are we doing here? You know, what are we doing here? So states absolutely have the experts. You have state departments of pesticide regulation, environmental conservation. You have fantastic colleges like Penn State that are working on this, that are localized experts. This is not something that the federal EPA has the full knowledge, capability, funding, or staffing to do. So we have to do it at all levels.
We have a couple of questions about organics. Are organic standards a meaningful way to encourage shoppers? And then we had somebody who asked about the standard watch nonprofits that consider impact on birds and insects. So they're asking about organic standards. Are they meaningful for shoppers? And then do the organic standards consider the impact on birds and insects?
Great questions. The quick answer is organic if you're financially able to, and if that's what your family can do, organic's the better way to go. There's at least a pretty robust regulatory process in place to make sure that more environmentally safe practices are being used. It's not perfect, nothing's perfect, but it's certainly a step in the right direction. The states with state laws are all blue states. How bad's the situation in the red states? We saw those maps. Yeah, we saw the maps. It certainly is somewhat the blue states. You know, New York, though, has a lot of agriculture. And at the state level, New York is usually pretty red or at least pretty purple. So that was very encouraging there. We are seeing this conversation shifting a little bit. And I have to tell you, it's the same players are the ones coming out to bat in every state. You're not usually getting the Iowa Association of Corn Farmers. It's the National Corn Growers Association. Those are the ones, I'm just going to pick on the corn growers because we all are. And those are the ones really coming out to push hard against it. So it's harder certainly to pass these in more typically red states, but as we'll hear from our other speakers, this is not something that's just limited to spotted owls and salamanders. This is something that very much affects people too.
Great, thank you. I'm now very pleased to introduce Dr. Kathleen Nolan. Dr. Nolan is a pediatrician, president of Physicians for Social Responsibility New York chapter, senior research director at the Catskill Mountainkeeper, and co-founder of Concerned Health Professionals of New York. Dr. Nolan is incredibly busy. She did want to join us today. Unfortunately, she had another conflicting meeting right after hours, so she is joining us on Zoom. Dr. Nolan will be presenting on the toxic truth, emerging science linking neonicotinoids to human health harms. Dr. Nolan, thank you so much for joining us today.
It's my great pleasure. Thank you very much. And I appreciate your accommodating me remotely. I also work as a legislator in Ulster County where I live. We have to take action at every level. And I chair a committee meeting that's happening just after this presentation. So really appreciate being able to be here and this very, very rich program. And this has been just wonderful. And I hope everyone has been enjoying it as much as I have been. I want to build on the presentations that we've already heard and talk about the relationship of neonics to other toxins that we've dealt with in the past, as the title of this conference implies, is are neonics a new DDT? So I am going to share my screen. I am speaking today with the support of Catskill Mountainkeeper and on behalf of the New York State chapter of Physicians for Social Responsibility. And this is the QR code to go to the Slido app, or there is a way that you can type in your questions there. I am now trying to tab forward again, and there, finally mastering the controls on this remote platform. The neonicotinoid insecticides, I think most importantly, we need to think about in terms of there being new nicotine-like compounds. And here again, you have a slide showing nicotine and showing a couple of the neonics. And you can see how close they are in structure. This is what they look like when they're painted on seeds. They're painted on seeds like this because they're dangerous. A person or an animal should not eat these coated seeds, so they are painted with these bright fluorescent colors. As we've heard, the neonics are very soluble in water. And though we say we don't eat insecticides, we actually do, because these neonic insecticides are taken up into the plants. And even though it is low concentrations that remain, if you eat a lot of food that contains neonics, you're getting exposed to neonics in the approximately 5% of the neonics that go into the crops. Almost 95% goes into water, and we also drink water. And unless water is charcoal filtered, it contains the neonics that went into it. So groundwater surface sources and surface water sources of water contain neonics. This is a slide to show the growth in neonics up to 2014. As we've heard, there's not good data about their increasing prevalence following 2014, but we don't have very much reason to suspect that that curve has slowed down. In fact, the information from Canada suggests that the neonics have continued to increase in use there until they made some government actions, took some government actions to change that profile. So this is a slide, I'm sorry for it to be so busy. It is my attempt to look at the question of, are neonics the new DDT? So we have the fancy chemical names for DDT and the neonicotinoids. One main difference is that DDT is more lipophilic, going towards fats, whereas the neonics are hydrophilic. They tend to be pulled towards water, but they have a lot of similar modes of action. Both stimulate nerves, and the neonics in particular have been shown to interrupt cell-to-cell communication. There are active breakdown products from both DDT and neonics, and as we've heard, they are very persistent in the environment. DDT said to be 2 to 15 years for a half-life. For half of it, what you put into the soil or the water to be gone, break down on its own. And with neonics, 1 to 15 years or more. So this is the reason that we can see persisting insecticide and breakdown products for decades. So the reason that we need to take action as soon as possible. These are not forever chemicals, so there is a little bit of a ray of hope here. When we do stop putting them into the environment, they will break down, and eventually we will have an environment that doesn't have these compounds in it. The primary harmful impacts of both of these agents, classes of agents, is hollowing out of ecosystems. They're just extremely toxic and toxic across many, many species. Ironically, I found that DDT is relatively non-toxic to humans at low doses. Not that I think that anybody should drink or eat DDT, but it is, in that sense, perhaps a little less of a problem than the neonics. Neonics in acute exposures mimic nicotine toxicity. So you get headaches, tremors, excitability, high blood pressure, tachycardia, a rapid heart rate, and you can have coma and death and seizures. But both cases, the long-term effects on humans are the most problematic, because very few people are exposed to either of these compounds acutely in doses high enough to bring on those toxicities. The figures, the symptoms and signs that I'm showing you there comes from a paper in India, where apparently they do have some problems with people ingesting neonics as an attempt for suicide. It can be effective for that use, but it's not likely. It's about 3% of people with very, very high exposures will end up dying acutely from nicotine exposures and neonicotinoid exposures. So very similar profile. In terms of long-term or chronic exposures, what you see with DDT is reproductive effects. We know that from the example of the bald eagle, and the thinning of eggshells and failure to reproduce young. But a part of the public attention to DDT came from the fact that there were questions raised about its carcinogenicity, and that gets public attention. With the neonics, we don't see as much of a concern about carcinogenicity. Adults can handle exposures to the neonics in ways that don't seem to generate as many problems. And that was by design. The chemical companies were looking for something that would be non-toxic to humans. And so they found this group of chemicals that mainly attacks a type of neuron that isn't so active in humans that are adults. But that particular neuronal synapse is very important during development. And so what you see is what's called teratogenicity. That's the leading of from exposures to birth with birth defects, congenital abnormalities. And these can be quite severe in the few studies that we have, and I'll talk in more detail about those. But they can be very severe from microcephaly, which is a small sized brain, to anencephaly, which is the absence of the upper brain entirely. And a high incidence of jaw deformities in deer, which I'll talk about, which mimics a high incidence of cleft lip and cleft palate from nicotine exposures during pregnancy. So very, very problematic research that I'll talk about in a little more detail. So I mentioned the public attention went to DDT very quickly, and it was the result of a few very concerned individuals. Rachel Carson with Silent Spring did us a huge service. And then there were individuals who at the UN and in the EPA that really picked up this cause. The EPA did result in a ban in the US in 1972, and the United Nations put the neonics, put DDT on their list of persistent organic pollutants in 1996. So there was effective action taken both federally and internationally. In regard to neonics, we haven't seen that federal action yet. And we can talk a little bit more about that later, or we might have some questions about that. But the states often can lead the way. And New York has done this. New Jersey has issued a ban on ornamental uses. And Massachusetts also has been taking action. And because of effective action taken at the federal level, the presence of DDT in the US is almost negligible, whereas we have persistent or increasing levels of the neonics in the United States, decreasing in Europe and Canada, where government action has taken place. So what do I mean about hollowing out of ecosystems? We know that the neonics do this because they have been used so pervasively in the United States and around the world that we have what I would call natural experiments, experiments in the wild. So you can correlate increased use with neonics with decreasing presence of worms and soil organisms, amphibians and reptiles, aquatic invertebrates, that's the insect larval stages and that fish feed on, and decreases in fish populations. We see problems with small mammals, mice, rats, rabbits, particularly in EPA studies of these compounds. And there are reports from the wild and some experiments done with wild white-tailed deer that are very troubling, because those are animal models that would be used to test the toxicity of a substance. And we're finding that hunters are reporting to us that there are problems in areas where the baseline of neonics in animals' blood is already quite high. And so, of course, that raises the question, what are the potential impacts to humans? I'm very troubled and want farmers to be troubled by the impact of neonics on worms and other inhabitants of soil. Those worms and beetles and other organisms are necessary for agriculture. There are wide varieties that have been reported to be harmed, either injured or killed by neonics. And neonics are the pesticides used in crop management that are the most over-purchased and irrationally used. And another research paper commenting on this said, among the 6 chemical classes of insecticides, the neonics are the most toxic to an earthworm adapted to decaying organic material. So not good for farmers, even if they had some beneficial uses that we could show in other areas. This is a natural experiment that I wanted to report to you from Japan. This was a lake that was quite well known for its production of eels and ice fish and smelt. And in the neighboring fields in 1992 to 1993, the agricultural folks there started using neonics. So if you look at the left-hand side of the slide, those high dots are all the different fish species that were known to be present in that lake. The only known change in that area at that time was the start of the introduction of the neonics. And you can see that almost all those populations declined. The smelt almost immediately to zero, and ice fish kind of struggled along for some time, but then also quite a pronounced decline, and eels as well. It's not known whether this was all direct toxicity on the fish or whether it was because many of these species eat insects that would have been killed by these neonics. And the question of possible synergistic impacts is raised here. This study said it could have been multiple different neonics that were used all working together, but neonics can also have toxicity that is combined with other agents that we're using. They're herbicides like glyphosate or other chemicals that may be in the environment. This is the slide to talk about the study that I mentioned. The study started with field observations that came in from hunters in Montana. They reported to the Fish and Wildlife Service that they were seeing small fawns, abnormal genitalia, and abnormal jaw link. And so some studies were done in Montana, and they documented that in 2002, 70% of male deer had genital abnormalities. And from 2001 to 2010, almost 50% of deer had some sort of facial deformity. These papers did not speculate on the origin of this, but researchers in South Dakota decided to try a trial. And so they captured wild deer and penned them and gave them increasing amounts of particular neonicotinoid in their water. So they could control the amount, and they gave some deer, the control group, no increase, no neonics in their water, and then a small amount, then a medium amount, and a large amount. Strikingly, they found that in their control group, there already was neonicotinoids that were found in the bloodstream of the deer. So they didn't really have a true control group who wasn't exposed. The control group of these deer had been exposed prior to being enrolled in this experiment. And we don't know for sure where they were getting their neonics. There's not, it may have been from corn, it may have been from dust from crops in other states even. but somehow they had elevated levels at baseline. And the studies documented what the hunters and wildlife officials in Montana had been concerned about. They showed decreased survival, decreased activity, decreased size of the fawns, and decreased health in the offspring, which they thought might be generally related to immune suppression. It was dose, there was a positive dose response curve. It was dose related. So this, as the amount of neonicotinoid exposure went up, the degree to which these abnormal findings were present increased. And the researchers again speculated about the fact that there seemed to be bioaccumulation, that is that there is an increase in the amount of neonicotinoids in the environment than we are actually actively putting into the wild environment. So clearly the neonics are not staying on the fields where they're intended to be used. These studies all raise very serious concerns for the possible impact of neonicotinoids on people. The acute toxicity has been demonstrated, as I said, in studies from India. Those studies do show toxicity patterns very similar to nicotine. Chronic toxicity has been evaluated in a couple of ways. You can look at case studies where individuals have been exposed and follow them over time. There are very few of those. What there are is just a handful of case control studies where one group of people was heavily exposed through living and working with agricultural exposures, working near croplands where neonicotinoids were being used, and another group that's very similar, that is chosen to be similar, that it does not have that same exposure. And those 4 studies that were summarized in a paper by Adrienne Semino, a graduate student at George Washington University in 2017, she reported associations between chronic neonic exposure and adverse development or neurological outcomes. So the adverse development is congenital malformations, including tetralogy of Fallot, which is a very severe, often fatal if not treated with highest level technology, heart malformation. Anencephaly, which I mentioned, is the absence of the entire upper part of the brain. Also, an association less strong, but there, with autism spectrum disorder, and a symptom cluster that included memory loss and finger tremor. These findings would be extremely troubling on their own, but when I went and looked at the relationship of chronic nicotine exposure, tobacco smoking in pregnant women, the findings were very, very similar. It was not so much tetralogy of Fallot, but cleft lip and cleft palate, which is similar to those jaw deformities that we were seeing in the white-tailed deer. There is evidence that exposure in humans is increasing. We don't have the slides to show the increased use of the neonicotinoids on crops, but we have a surrogate, unfortunately, in human measurements of neonic levels in blood and urine. And the CDC finds that half of Americans are exposed to neonics on any given day. That's in 2016. It was a little higher in 2019. And most worryingly, a very recent study in 2022 of 171 pregnant women across 5 states in the Northeast showed that, that neonics were present in 94%. And the study ran for 3 years, and in the 3rd year, the levels were higher and more prevalent than in the 1st year. And there was also a higher incidence in Hispanic women. So we don't know why there is that higher incidence for sure, but we do know that organic foods have fewer chemicals in general and fewer insecticides and fewer neonics. Are Hispanic women in those 5 states able to have the same access to organic foods? I suspect not. Is it related to where there are concentrations of Hispanic women and non-filtered water sources that have high neonic levels? That's possible. So there's definitely work that we need to do. And in my mind, we have to not just encourage people to eat organic and filter their water if they live in a high neonic area, but just get the neonics out so no one has to worry about that. On this slide, I reiterate the birth defects in heart and brain that have been found in case control studies, the autism-like symptoms. And I didn't mention these are other studies showing that in adult men exposed chronically to neonics, there's decreased sperm quantity and quality and decreased testosterone, insulin regulation, and changes in fat metabolism. So these kind of findings suggest that maybe the neonics are behaving as EDCs, endocrine disrupting compounds. I want to go back that in the studies that I'm citing here, I have not yet included any of the very large number of studies looking at a single neonic that is present in pet collars and all of the reports and research on seizures of pets and in some cases humans in those households related to those pet collars. It's needs to be done, and there are literally thousands of reports there, and so I haven't included it enough to I haven't studied it enough to include it and report on it here. But I am worried, and I do think it is another part of the picture, which brings me to this last slide. What we need to do in terms of protecting health is recognize patterns. That's what was done with DDT. So here, what is the pattern? We have a chemistry that shows us a structure that's like nicotine, which is a terrible compound that I've worked all my adult life to reduce exposures to. You have a toxicologic profile that is horrible. There's a highly, highly potent, highly toxic group of chemicals, lethal across many species, including insects, birds, and I didn't mention earlier, bats, fish, soil organisms. We know its mechanisms of action, that it interrupts neurotransmission and it possibly has endocrine disrupting activity. And we have good evidence to suggest that it may be teratogenic, certainly in mammals and large mammals and humans being another large mammal. Ecologically, it hollows out ecosystems, this group of compounds, and the animal studies are very troubling, the human studies very troubling, and your risk-benefit profile is terrible. It's extremely high risk and very low benefit. So why haven't we gotten rid of it yet? I think that the answer to that is partly that we need to have the increase in public attention. That is exactly what this conference is doing. And I do think it's valid to target neonics initially, because it's much easier to move on something where there's this much evidence than to generally get agricultural practices to change. That's a big goal, and it's a worthy goal, but it's a longer term goal than focusing on those compounds that we can create this kind of picture and present to our lawmakers and ask them to do something. So yes, we should eat organic. We should filter our water if we live in an area that's either been tested and has high neonic levels or has large agricultural use, where I think you can assume that you're going to have some high neonic levels. But we need to deal with this problem in a more universal way, a fairer way, and a way that is more secure so that everybody knows that the food that they eat and the water that they drink is going to be healthy for them and nourishing. So we have a path ahead of us, and we have some choices to make on exactly where that path takes us. I'm very encouraged by what we've seen here today, from the other presenters and from the quality of the questions coming in. So, and I'm looking forward to the next presenters. So I will stop here, and if think we have time for some questions, if that's if the organizers agree.
Thank you, Dr. Nolan. The research is really quite compelling, and thank you for sharing that. We do have a couple of questions that were coming in. Can the human body eject neonicotinoids, or does it accumulate in the body?
I think those are two different questions. It does accumulate in the body. The more you eat, the more that you will show the presence of neonics in your body. It is metabolized and excreted, so you can clear that. And I don't know the time frame for that. I don't know that that's been studied. So that's in terms of the accumulation. The first part of the question was,
But does the body eject it, or does it accumulate?
yeah, does it adapt? Human adults that are exposed to neonics have an acute reaction and then don't seem to go on to other harmful effects. I don't think that's because they're adapting. I think it's because they're excreting or secreting the neonics and their byproducts. But that is not something I know for sure. The reason that I think we have developmental abnormalities with these exposures is that the developing embryo and fetus cannot adapt. That's not a period where adaptation can take place. And the miracle of normal development requires such intricate cell-to-cell communications and such exquisite alignments of timing that I don't think there would be any way to develop humans that could be safe from these type of exposures. I think we have to get rid of the exposures.
Thank you. And in relation to that, autism spectrum disorder occurs in 1 out of 36 babies versus 1 out of 10,000 in the 1970s. Do you think we could correlate that to the increase of neonicotinoids in our environment?
I've been hesitant to make that a one-to-one correlation because there are so many changes that may be related to the development of autism spectrum disorder that have been studied. So separating out the contribution of neonics would be very troubling, and autism spectrum disorder and autism are probably multifactorial, many different factors. However, if you look at the if you overlay the charts showing the increase in autism spectrum disorder with the introduction of neonics, you get you do get a bump in the 1990s and 2000s, you know. But between 1970 and 1992, we didn't have very much neonic use, if any at all. They're a newly developed group of chemicals. So are neonics making things worse? It would be the question that I would be able to say, I'm worried about that. And I am starting to be willing to make the association and to look into nicotine, you know, tobacco products and their relation with autism and autism spectrum disorder, because I'm so convinced now that we can use nicotine studies as a surrogate for neonicotinoid studies, which might be harder to come by.
Two questions that are somewhat related. One asked, is there a way that individuals could test their soil and well water for neonicotinoids? And the other one asked, how would we check for the presence of neonics on our personal veggies that we buy?
So Soil is difficult, but it could be done by specialized laboratories. Water is also specialized laboratories, but easier. And it's going to be a very good surrogate since so much of what's in the soil will run downstream. So if you can get water that is downstream from soil that you're worried about, you can test for that. And that you can go to your county health department and ask them to give you biological labs that might be able to test. There are a lot of labs now that will screen well water or surface water for 200 different compounds. They might not be screening for neonics yet, but they might be able to add it. Or they might have some other insecticide that you can screen for. And if you find any elevation, then you would want to assume that you're at risk for neonics as well. Neonics cannot be washed off the outside of fruit. It's one of the things that made me really take up this cause. If you could wash this off your fruit and reduce your exposure that way, then okay, we have some control. But the chemicals are grown into the plants in ways that make it impossible to extract them, except as one of the other presenters mentioned, perhaps through some extreme chemical means in a laboratory. So we need to prevent the neonics from being applied to things that we're going to ingest as food.
One question that asking if nicotina flowers are dangerous to pollinators.
What's the question again?
Are nicotina flowers poisonous to pollinators?
I don't know nicotina flowers. We'll need one of our gardeners or pollinator pathway people to help me out on nicotina. Nicotine is largely these days produced synthetically, although you still can get it from tobacco, and some portion of it is from tobacco. So that's the major source of nicotine. Things that are named for nicotine, I may have that association as worth looking into. So thank you for the question.
So we have a couple of questions that are around children and or animals playing on lawns that are coated with neonics. One asks that if the youth sports playing on playing fields, if they're vulnerable, or a child playing on a neighbor's non-organic lawn. And the other asks if a pregnant woman could contact neonics from petting a dog that's been playing on a treated lawn.
Fortunately, neonics were introduced into agriculture with such fanfare because they're much safer from surface contact than organophosphates and some of the older insecticides. So surface contact isn't a predominant way to get exposures. However, I wouldn't be completely comfortable with playing on a lawn that had just been treated because there can be some of the chemical get into the air. But our main routes of exposure are ingestion rather than through topical contact with our skin. Children do show higher levels of these chemicals, perhaps because they eat less organic food. Most baby foods do contain insecticides, including neonics. So it's primarily from ingestion. But if I had a choice to avoid an exposure on a lawn or a golf course, I would avoid it. We haven't studied all of the long-term impacts. So again, I think it's a question that highlights that we are having to be too careful in our world because we're allowing a use of these chemicals that's not beneficial and could be stopped.
Thank you. As a pediatrician, one of our participants asked, are pediatricians and OBGYNs warning parents about this issue, and do expecting moms know about this?
I would invite the questioner to work with me. I think that it's past time that we should have some articles in pediatric publications and in materials going out to pediatricians to warn them about this. We've been focusing our efforts on trying to limit the use. I live in New York State and saw the opportunity to try to get a statewide ban. So that's where my efforts have been. Now that we have a lead-in period to the ban, I hope to turn to doing more to get the word out. And I would welcome others to join in that and maybe make recommendations for medical societies to include conferences and presentations on this at their meetings.
Thank you. Are you aware of any data on birth defects and health impacts in the Great Plains states on farmers and their families due to drinking water contamination?
I haven't yet investigated that. I think that is a study crying out to be done. I will caution, though, that I did try to do some studies in New York State when I first started working against fracking. And I wanted to look at birth defects related to fracking waste. The birth defect registries in New York State at that time were 10 years behind. And so I had an obstetrician report to me, very high instance of a particular birth defect, gastroschisis, which is an abnormal formation of the lining of the skin at the trunk. And so the internal organs of the abdomen protrude out through an unclosed opening in the abdomen. I knew that the amount of that abnormality that was being seen by that obstetrician was very, very high, but I was not able to, from registries or by calling the state, get up-to-date information. I should probably go back and look at that now, although we did end up banning both by regulation and by legislation fracking in New York State. But that's crying out to be done. And I think that those studies out west, the populations in Montana and South Dakota are sparse. So it might be hard to show it in humans. They have a lot more deer. So I think that's why we have the studies with, with where we can get enough samples to be able to discern patterns.
And one final question. Have you seen any correlation between neonics and type 1 diabetes?
I have not seen that reported, but there are those studies in men showing abnormal insulin function. So that again, showing changes in insulin resistance. So I think there's a whole, I'm sorry to say, a whole world ahead of us in terms of researching the harms that we have done. And if we don't get these laws on the books to change and prevent the uses of these compounds, then we should shunt a whole bunch of funding to the research so that we can prove to lawmakers all that I've been saying here based on very early evidence.
Well, Dr. Nolan, thank you for joining us today.
Thank you very much.
Now I'd like to invite Ann Gadwah to the podium. Ms. Gadwah is an advocacy and outreach coordinator for the Sierra Club Connecticut. She'll be discussing Senate Bill 190, the current proposal for regulating neonics, which is now before the General Assembly. And Ann has been putting together a whole bunch of talks and conferences. And if you know people in your community who have not come out for them, the next one is going to be April 9th in New Britain. So,
My name's Ann Gadwah, and I'm advocacy and outreach organizer with Sierra Club Connecticut. I've been advocating at the state capitol for legislation that would ban neonicotinoids on non-agricultural plants for the past few years. I come from a background that's heavily invested in protecting ecosystems and wildlife, so this is not only my job to try to get this legislation passed, it is also my passion. And I'm just going to briefly go over where we are in terms of advocacy surrounding the pesticides in Connecticut. So a bill to ban neonicotinoids was introduced in both 2022 and 2023. In 2023, it was part of a bill that would ban both chlorpyrifos and neonicotinoids from non-agricultural use. It was amended to remove the section on neonics, but it did keep in the chlorpyrifos language, and that did pass, which is a win for us and birds and bees and the ecosystems, of course. In 2023, the bill came out of committee, but was never called on the Senate floor. The main sources of opposition for both those years were landscaping and lawn services, golf courses, and chemical industry lobbyists. There are several states that have stronger neonic laws than Connecticut does. Nevada, New Jersey, and Maine have all laws that prohibit their use on non-agricultural products. Similar to Connecticut, Maryland, Vermont, Colorado, Massachusetts, and Long Island have laws that restrict their use by homeowners on their own lawns. Like Connecticut, Vermont's currently working to strengthen this law as well. They're in sort of the same position we are. I have some friends that are lobbyists in Vermont that have been talking about this and wanting to work together to share some, strategy. But in New York, we have that unique scenario that we've heard about today, that they just passed a law that prohibited the use of unneeded neonic coatings on corn, soybeans, and wheat seed, and non-agricultural lawn and garden uses. This is a huge win for the birds and the bees in New York, and we're ready. We really should strike here while the iron is hot. We're hoping to really ride the wave of momentum that the New York bill has created this year. So in all of these cases, these bills were passed by folks like you. Coming together to form coalitions, lobbying their representatives, writing to the press, writing letters to the editor and op-eds, holding events like this one to get the information out to the people that need it. Currently, there's a bill raised in the Environment Committee, it's Senate Bill 190. That stated purpose is to restrict on all non-agricultural use, but unfortunately exempts so many of the most common uses, it basically renders the bill ineffective. There was a public hearing on Friday where many folks came out to ask for language and brought up many of the dangers of the pesticides that you heard today, and a link to a lot of the facts. It was pretty great. It was pretty amazing. The biggest opposition came from the golf course lobby. I don't know if anybody here had testified on that or saw that, but they can use any little bit to kind of get their point across, and it's quite frustrating. So when you think about the money that golf courses have, when you think about the money that the lobbyists have that work for the golf courses, I mean, it's a multi-million-dollar industry, right? So the only way with that power and that money for us to be able to balance the scales is for people like us to really come in, and it will balance. The money and power with people power will balance out, and we'll be able to get this legislation passed. So advocacy for the neonic ban can look like contacting your own legislator with a phone or an email. Please, your own legislator. They will respond to you. If they get 10 calls on an issue like this, they'll think it's 100 people in their district that want that. If they take the time to write the email, do a phone call, you can go right on the Connecticut General Assembly website and find your legislator if you don't know who they are. This is a Senate bill, so contacting your senator would be good for this. So would contacting obviously your representative, and you can push them a little bit to tell their friends in the committees that they want this bill to not only pass, they support it, but also we'd like them to support it. Environmental committee leadership, have them talk to them. The committee leadership won't necessarily listen to folks if they're not in their district, if they're not, part of their Senate district, but they will listen to their other legislators, and your legislator will listen to you. Ask them to be a champion for protection of birds and bees, stronger language. There is lots of information we have, lots of links on what kind of language would be stronger for Senate Bill 190. I have it up right now, actually, and I can tell you what it says for exemptions. Yeah. The exemptions for them would be by a licensed arborist or licensed ornament plant applicator, for indoor and structural applications by a licensed pesticide applicator, a licensed applicator for protection against ticks and mosquitoes, a nursery, or a golf course superintendent on a golf course, which besides people using it, it's everything, right? It's it's basically just reiterating the language we already have in law. right? So it's not a great bill. But pressure to amend it would be good. Pressure to amend it would be good. So other things you could do, all of our organizations have action alerts and fact sheets. If you need any of information for your phone call or for your email, take a look at our websites, take a look at where we can have action done. Write a letter to the editor, if these legislators are opening their newspaper and can't get away from the neonicotinoid issue, like that's gonna have an effect on them too, right? That's gonna have a really good effect. And a good way to start with like letters to the editor is to talk about how you came to this conference and how you're really inspired to make some change. And, this particular speaker was right on, and you really think that the legislators and the legislative body should do something about it. Come to advocate at the state capitol on a lobby day, wearing your best bee outfit. Victor will help you out in that for inspiration as always, as will Tanea. And finally, if you use a landscape company, nursery, people that do this, ask them what they use. Like government is one level of society that we can make a change, but the businesses too. If businesses are hearing enough that they don't want that your customers do not want you to use neonicotinoids, they'll adjust. They will. It's the bottom line. So I'm happy to answer any questions you have. If anybody is looking for a lobby opportunity with folks of your same, that care about the same issues you do. On Friday, we are having a lobby day at the Capitol. We'll be in room at 310, which is in the state capitol on the 3rd floor. You'll learn about all the issues that Sierra Club cares about, and one of them is neonicotinoids, rodenticides, toxics, right? PFAS as well. And from 9 to 10:30, and then we will go talk to our legislators. And there's nothing more impactful for legislators than somebody in the person. We'd like 5 of us. So happy to answer any questions, and thank you so much for your time.
We have a couple of questions. Somebody asked, are you in favor of the Audubon International certification for golf courses, and can that certification be trusted?
I can't answer that question. Can anybody from Audubon answer that question? I don't know. I'm sorry.
Yeah,
Go
unfortunately.
ahead. Already go ahead. I'm sorry.
I'm not
National Audubon, so.
Okay.
But I will speak to it. The golf course certification has some really fantastic parts in it. There's a lot of native plant requirements that go into it. It can be a little fudgy on the pesticide parts of it though, but by and large, it's certainly a step in the right direction. It's much better to be certified as a golf course with that than it is to not be certified. So
thank you.
Yeah.
The knowledge is always important.
Thank you, Hardy. So for those online, Hardy said better to be certified, and there's a lot of good things that are in it. What are the chances we will get a better bill this year?
I think pretty good. I think strategy wise, I think that we have momentum there. I mean, just the fact that we have a bill this year, like the prevailing knowledge before we actually had a bill, or the prevailing thought, is that we were gonna have to just kind of like build momentum for next year. So the fact that anything's even coming out makes me believe that there will be some. And I do think that folks on the committee have been working to educate themselves more on this issue. I feel like they are getting a lot of pushback from golf courses and landscape companies and everything. But like I said, if we can keep up the momentum, then we should be able to get something passed this year. And even if some of these exemptions do stay on there, some of them are gonna come off. So I think it's gonna be on Friday. So keep your eyes and ears on, because they are screening today. And then on Friday, they will vote on whether or not to bring it out of committee. So hopefully.
Which leads right into our next question. Somebody asked if it passed last Friday, but it did not. It's going forward this Friday.
Yeah, it was the public hearing on Friday, so they were hearing arguments for and against what we should do, that sort of thing. It was like open to the public to come and testify, which is really a fun, good thing to do too, for other issues that you all care about, even if you just do the written testimonies.
How's the rodenticide bill doing?
The rodenticide bill is doing well. It came out of committee on Friday, and it had substitute language, and the language in it reflects the moratorium from California, which was what the coalition, the animal advocates and the Friends of Animals were advocating for at the beginning of the year. So it's in good shape. And now it has to pass the House and it'll have to pass the Senate, and they're, haven't had any real, session days yet, but those will be coming out. So, contact your legislators about that bill too, because that would really make a huge difference. To the point about the bald eagles, like, I haven't seen any bald eagles in my life until I went to Alaska in 2009, and now I see them a lot. And that was, in the 1980s, we didn't see them like we do now, right? It's amazing. It's like something that oh, God, I get the chills just thinking about it. Anyway, of really being able to make a difference. This is exactly how people did this, right? Is listen to the science, advocated for it, got people in the gut about the bald eagles, about the birds, about all these things. So we can make a difference. And you don't have to be an expert on all of things. You can just go in there and say, this is what I've learned and this is why I care about it. And that's more impactful sometimes. The emotional stuff, the stuff that gets people in the gut. I mean, that really is the impactful stuff that moves people's hearts. I mean, you can move people's brains too, but we all kind of lead from the heart as much as we try to think we don't.
We had several people are asking how long do they have to submit testimony? So when should testimony be submitted?
So so they'll be voting on it on Friday. You can still submit written testimony up until they voted out of committee.
And you'll be sending out more information about the Friday lobby day?
Yes, I will. Absolutely.
Legislators will be in session, so
Yep.
it won't be easy to talk with them.
Yeah, but if you do want to come, we suggest reaching out to your legislator yourself and say, hey, I'll be here on Friday. And even if they can only pop out of something for 5 minutes, they will, they will for constituents especially, and if this is something they care about. So yeah, it'll be a little it might be a little crazy, but I think it'll really be fun. And it's really nice to be with other folks that care about the same things that you do, because it just kind of that momentum. That's what I always kind of get, this kind of thing, being at the Capitol all day kind of sucks some life out of me, but being at things like this, it really puts it right back in. So I'd love to see all of you there.
So and we had somebody ask, does it help to reach out to legislators on social media?
Yes, but it's more of a call in than a call out, right? I think that, you can say, I support this bill, could you please vote for it? And then you'll get some likes, and then yes, they'll say it. I did get personal story is a couple of years ago, there was a bill to limit the big five from Africa from coming into Connecticut, if you all remember. It was the Cecil bill about bringing in the trophies from elephants and lions and different and giraffes and different animals from Africa, right? And I tweeted out to Bob Duff saying, hey, thank you for doing this, and I'm really glad we have your support. And he liked it, retweeted it. I was very excited. So they do notice on social media. But I mean, I'm not saying you can't be critical, but calling in is more effective often than calling out, right? If being hey, I'd love to talk to you about this because it's so important to me, kind of thing. And sharing information. So yeah, I do think it's worth it to reach out to them on social media.
So just to restate something, I think you said it earlier, was that private landowners, individuals can't purchase Neonics at the current time. It has to be purchased by certified applicators. So it's not that you could get it in Walmart, but you could still potentially get it online. I mean,
Yeah.
But then somebody asked, as a potential method of working with golf course people should we stress the issue of the impact on testosterone for golf course supers?
No comment really, but whatever works, because that's definitely a hit you in the gut issue, right? But yeah, I think a lot of times, I mean, I hate to say it, a lot of times people don't care about things that directly affects them. So saying to people that this could affect you personally is not the worst thing that you can do. Yeah, is that it? Thank you. Okay, great. Thank you.
So our final presentation, thank you, Anne. Our final presentation is a panel discussion on water contamination, declines in biodiversity, and where we can go now. Our panelists include, and please, if the panelists could come up. If you could just raise your hand as I introduce you. Karen below. Ms. Below is a biologist in the New England Water Science Center at the United States Geological Survey. Karen's work entails exploring relations between physical, chemical, and biological data in rivers and streams at both the state and regional levels. Richard Harris. Mr. Harris founded Harbor Watch, a water quality monitoring organization in Southwest Connecticut, and monitors the water quality in several harbors for Norm Bloom and Son Oyster Company. And Mr. Harris is also a member of our Coalition for Pesticide Reform. Victor Damasi. Mr. Damasi is a lepidopterist and affiliate at Yale Peabody Museum and also a member of our Coalition for Pesticide Reform. Dina Brewster. You guys lined up in order. Wow, I'm impressed. Ms. Brewster owns the Hickories Organic Farm in Ridgefield and is the former executive director of the Connecticut chapter of the Northeast Organic Farm Association. Bert DeMarsh. Mr. DeMarsh is president of Laurel Rock, a residential landscape maintenance company in Wilton, Connecticut. Bert holds a commercial pesticide license and is a landscape industry certified professional. Laurel Rock is a leader in sustainable landscape practices. Thank you for joining us today.
Hi, everyone. My name is Karen Boyer. I am a biologist with the U.S. Geological Survey in the New England Water Science Center. I sit in the Connecticut office, and I am going to discuss with you today the neonic imidacloprid in Connecticut rivers, and these are results from 2 U.S. Geological Survey projects. So up here, I am showing the distribution of sites where we have collected pesticide data. The first 16 locations were part of a Northeast Stream Quality Assessment project, and the last 2 locations are part of a national water quality network. The 16 initial sites were part of a short-term study, and the last 2 are part of a longer-term study, which I will describe both in a little bit of detail. For the Northeast Stream Quality Assessment, it's part of a larger effort called the Regional Stream Quality Assessment, where those studies occurred in 5 locations across the United States. The goals of the RSQA are to characterize multiple water quality factors that are stressors to aquatic life, including contaminants, nutrients, sediment, and stream flow alteration, and to develop a better understanding of the relation of those stressors to ecological conditions in streams throughout the region. The Northeast Stream Quality Assessment occurred in 2016. We had 95 locations throughout New England and New York, a couple locations in Pennsylvania and New Jersey also, and 16 of those locations were in Connecticut. There's a report that was put together that describes in much more detail the design and methods that were utilized in this study, and there's a link underneath that will bring you to that report. So again, these are the 16 sites that were sampled as part of this effort in Connecticut. I just want to discuss the results that we found. Each of these site locations were given a site type based on the land use in the watershed. In Connecticut, 2 of our sites were forested. 6 of them were light urban, and 8 of them were considered urban. We detected imidacloprid in all of our urban locations and 1 of our light urban sites. And essentially those sites fall along our urban corridors, essentially close to 91, Route 84, and 95. So the other 2 sites that I'm going to talk is our long-term study, the National Water Quality Network. We have 110 locations across the United States, And this network was established in water year 2013. 4 of our sites in this network are in New England, and the 2 sites where we collect pesticides are located in Connecticut. Number 17 is the Connecticut River at Thompsonville, and 18 is the Norwalk River at Winnipock. During the 10-year timeframe, we've collected 175 samples at Thompsonville, and we had 24 detections of imidacloprid. During that same time frame, we collected 229 samples in Norwalk, and we had 145 detections of imidacloprid. The Norwalk data is much more robust, and I went ahead and summarized those results by month. The number after the month indicates how many samples did have concentrations of imidacloprid. As you can see, the majority of our detections occurred during the summer months, which is probably no surprise to everybody here. But I did also want to show that every single month of the year, we did have at least 3 detections of this constituent. I did not summarize the 24 detections that we detected at our Connecticut River location at Thompsonville. But of the 24 detections, 23 of them occurred during the summer. So again, just a great visual of that information that we collect at our long-term location in Norwalk. So in summary, the short-term intensive NESPA study was able to provide us a snapshot of results during 2016 of many sites in Connecticut, while the long-term National Water Quality Network sites allows us the opportunity to perform seasonal and trend analysis. I want to mention also that our data are publicly available through the National Water Quality Monitoring Council Water Quality Portal. It's a mouthful. And I just wanted to end with some pictures of some of our technicians in Connecticut collecting a water sample at the Norwalk River in Winnipock and also performing a discharge measurement. The center picture shows how we process the water after we collect it from the river. And then that last photo is a 40 ml vial, which we sent into our National Water Quality Lab in Denver for pesticide analysis. Thank you so much.
Hello, I'm Richard Harris. Looks like we're thinning out here. I just want to tell you that I'm glad to be here. Give you a little bit of background on myself. I worked for Shell Oil for 27 years. I know both sides of the fence. I was a district manager for chemical, for oil. I came out of that and I decided I want to set up my own environmental activity. Fortunately, they moved me. My final move was to Westport, Connecticut. And I started to learn all I could. I finished up a degree in marine sciences too over at NYU on Long Island. And while I was there, one of the key figures I ran into was Charles Worcester, who was the founder of the what was the name of it? Skipped my mind. He founded an organization and he started teaching me about DDT. And it was quite an eye-opening for me, working for an oil company to come in to an academic thing like that. And environmental defense is a group he put together. He gave me all the ins and outs. I said, well, how did you find out about it? He said, I found robins hopping around in the woods with tremors. And we analyzed them and found out it was DDT. And it expanded from there. As you all know, it went higher into the food chain. It was absorbing animal fats. So those fish that got small fish were eaten by big fish, were eaten by the raptors. The raptors tried to lay eggs. The shells never materialized because an endocrine was missing. He finally, with great effort, got the whole thing canceled in 1972. And I was amazed that, one man's effort with about 2 or 3 other scientists had pushed this whole thing through. Shortly after that, Aldrin and Beelden went down the tubes and they started knocking off all the fluorinated hydrocarbons. Tremendous success. And you would think at that point, maybe we learned a lesson. Maybe we learned something. Because gradually it was pushed out of the environment. The record was recovered with great effort by bird groups. Today, I go look down along this coastline and look at all the birds. They're there, but there's some missing ones too, and that's what I want to talk about. This is, until I heard this session today, this is all I knew about the Norwalk River, right there. And you can see, you've got something like 218 pesticides and USGS identified 30 of them in the Norwalk River, 30 alone. And you can see how they broke out. You had 18 to go to human benchmarks, and the others went over to pesticides, and imidacloride came out as the only one that would have an effect, was it exceeded the safety levels for the environment. So I'm going to relate that to a couple things. Over the years, I was always very interested in supplies and fish populations. And one thing I used to do is put a minnow trap off the end of our dock in Norwalk and see what came into it. During the first couple of years, about 10 years ago, it was stuffed with oh, I'm sorry. Before I move on, there is the results of the tests on that one product that exceeded the natural limits for wildlife. Okay, those fish were always in the traps, minnies, I'm sorry, killifish, and various types of small minnows that lived in the estuary. In fact, when they lift the trap out of the water, some days it would be so stuffed, you couldn't get another fish into it. These started to disappear. Today, if I were to put that trap back in the water, I might catch 1 or 2. You say, oh my God, this was a fish non-commercial. Who pays any attention to that, right? But the result that we saw was at low tide in the old days, you used to have an array of water birds, wading birds that love to be up there catching these guys. And I can give you just a few names. We had egrets, we had green herons, we had black-crowned night herons, we had little blue herons, we had blue herons, yellow-crowned night herons, and usually there was 50 to 100 birds there. Okay. Today, I still monitor water and always harbors for oxygen, salinity, temperature. I go up there, there is 2 egrets, maybe. One day, maybe a blue heron will be there. That's it. That shouldn't be so troublesome, except I monitor 7 harbors. I do Stanford, 5 Mile River, Norwalk, Saugatuck, right on up. Housatonic. It's all the same. I used to be in those harbors all the time. I still am every year. We make 7 or 8 trips a year to each one, doing oxygen, salinity, temperature, bacteria. Uh-oh. I'm down to a few egrets. So that's a huge impact. Now, what happened? Did the pesticide knock out the zooplankton, which is the food for these fish? Did it poison the fish? Because we know that at certain levels it will kill fish. They're gone. And this is the estuary, okay? So that bothered me a lot. I took a little look at crustaceans. I don't know if you guys remember, we used to have a great thriving lobster industry in Long Island Sound. Then we had some geniuses that decided to get rid of mosquito larvae. The best way to do it was to put enrichment down the drains. And all the cities adopted that. Oh, this is a great idea. We finally got a hurricane, flushed all that out at once. And that result was we killed almost all the lobsters. It was really sad. It went from several $1 million a year industry down to about 35,000. Bloom, the guy I work for, he has one of the remaining lobster boats. And the only place they find him is a couple of deep holes in the western end of the sound. That was quite a hit. Nobody reported on the number of crabs that were killed, and apparently there were many of them coming up. Blues, rock crabs, Jonah crabs, calico crabs were all coming up dead in the nets as well. So if you look at that little drawing there, what you'll see on the left-hand side, if you look at the bars, up until the late 90s, We had a very diverse population. Look at the top of those bars. You'll see a lot of little different colors. That was diversity. That was populations that were well matched. The big slump there comes because, first of all, we got the state, we did this to the state put us off the job for a while. We weren't able to get back until there was a 3 or 4 year lapse there at the end of 1990. But you can see, I think what happened was the pesticide had residual effects. And it took that population a long time to come back. Look at the right-hand side. You don't have the diversity anymore, right? You got blue crabs, for some reason, they're highly resilient and they're hanging around. You've got you've got long-clawed hermit crabs, and you've got a few spiders. That's where we are today. The fishermen, I have about 7 or 8 fishermen that work for Bloom all the time. They tell me what they find. They came in and said, "Dick, we're not getting any more crabs." Is that part of this pesticide? Did that do it? I mean, who knows? All I knew as of a few minutes ago was that one graph I had showing me that Norwalk River back in 2016 had an alert out for pesticides, one in particular. Pretty scary. So my question is this. In my early days of Harbor Watch, should introduce my companion over there, Peter Faboni. We taught extensively insect populations in streams. We had classes where we would take kids out of high school, line them up for the summer, give them a course. And it was in this. We would take them out and show them the crab, show them all the insects that you see there. And you name it. Dragonflies, mayflies, caddisflies, black flies, they're all there, all the larval forms, and then the emergence you start to see on all the banks. Now, I have got a recent check of these streams of the upper Norwalk River and Saugatuck River, where we used to do this. But there is one indicator. Up until a few years ago, I live only half a mile from the stream. All of a sudden, I would see these insects showing up, such as dragonflies, mayflies, right? Dragonflies would come into the yard and they'd stay all summer and work on the gardens we had. And I get to work in the morning and step outside, they'd be all warming up on the pavement, getting ready for another day's work. All of the stream insects showed up. Tiny toads the size of a dime would appear in the yard. How did they hop that far? You know, I would walk down by the river and find that today, no eggs, no frog eggs, no salamander eggs, no sign of that kind of life. And then you wonder, it's time we did this. Go take a hard look at it, because my guess is a lot of that stuff is missing. Because my house was an extension of the river. It was all there. And it wasn't just that. We had a garden, and Vic's going to talk about butterflies. We had a garden with a tremendous amount of butterflies. Last summer, it was 0. Louise was nice enough, my partner, to give me some milkweeds. And for many years, we used to have them come in and take the milkweed. No, not this time. And you begin to look around and say, wow. And when winter comes, you have the normal line of suspects standing at your door waiting to get inside, right? They're gone too. Click beetles, shield beetles. There's small salamanders trying to get inside. Wasn't anybody there this year. We used to have my kids, insects. We used to have at least one cricket that would get under the radiator and croak away all 2 or 3 months. The kids would take down a cup of water and leave it there and some lettuce. So proud about keeping that cricket going. He didn't show up this year. We used to have a crane fly on the bathroom mirror. You guys have seen them, right? You're shaving them more. What the hell is this? A big mosquito? No, it's a crane fly. It came out of the river. No, we didn't see them either. Yeah, I'm getting lonely. I'm looking around the yard. It used to be a garden. It used to be thriving stuff. No. And most of that stuff came from the river. Okay. I'm just getting into this now. I'm just getting into insecticides. We've done a lot of work with Louise with PFAS. And I should say, my other partner up there, Jason, is we belong to East Norwalk Blue. It's split 2 ways. He manages 4 pump out loads from Stanford all the way up to, and that's what we do. Thank you.
Okay, I'm Victor DeMasi, and I'm a lepidopterist. a filthy word. And it's a person who's passionate about butterflies. Next. And we're gonna go just briefly to my house in West Reading and look at the butterflies in my backyard. This is what the backyard looks like from the attic. I could have mowed it and put condos there, but I didn't. Next. And this is, we found almost 50% of the state fauna in the 40 years that we've lived there. All my specimens are at the Peabody Museum. I'm not actively collecting these anymore, but on the way out, I brought this collection today. If anybody would like to see it, what diversity looks like in Connecticut. Next. Now, every year I've been part of a program called the National Butterfly Association 4th of July Butterfly Count. And we go through meadows and count the number of butterflies we see and the diversity. Reading has some of the best meadows in Connecticut. This is the Baltimore checker spot, named after Lord Baltimore, the first guy who started Maryland, not thinking of all the Indians and everybody else that lived there. But this is an absolute stunner. It is a very rare butterfly in Connecticut. We've had it at 2 different locations in our count, so it gives you an idea of where we're counting. Next. Okay, so anyway, and this is me. You've heard of the fly catching macaroni, famous in ancient England. Well, this is the modern fly catching macaroni. Next. And we go out at the 4th of July and count. In different years, we have different groups of people. We try to get as many young people as possible to introduce them what nature looks like in their environment. This particular year, we had the 4th of July butterfly count had the National Lepidoptera Convention at Yale. So we got some real big names in our count group there. Kim Garwood, great international photographer, and Rick Check, he's the author of Butterflies of the East. Next. And what I'm trying to do here with this talk today, brief talk, is to give you an idea of where some of those metrics, some of those numbers on all those charts we got submerged with for the last 4 hours. I mean, somebody's out there counting. So here's some people counting. This is the start of the count. We fan out and we work across the meadow. Next. And like everything, you have cheaters. Here, one of our counters is trying to get a giant moth into the butterfly count. So never, you never can rest, right? You gotta watch your back. Next. And we're talking about neonics in the environment, and I'll get to my conclusion in a few slides, but here we are lobbying in Hartford for pollinators and stuff, and my aide, Lucas Harris, has sprinkled toxic pollen on me. So part of the sad part of the neonicotinoid. When I fell down like this in the Capitol lobby building, everybody thought I had a heart attack. And a bunch of people came over, running over, including legislators. And, hey, that's what you gotta do. You gotta get that. Next. Okay, but the neonics, we got the information today. It's killing birds. And it's hard to put an exact finger on how it's doing it, when and where, but it's happening. Next. And this is one thing that killing insects aggravates me most of all, the backyard bug zapper. The studies that were done at the University of Missouri on this found that it was killing everything except the target organisms of mosquitoes and black flies. So people have to get rid of their mosquitoes. Next. But we've been counting for 30 years now in Reading, and it's the same locations. We haven't really lost spots to development. They're all the same meadows they used to be. And we count each year for how many and how many different kinds. So what we really see is the different kinds are to a large extent still there. There's still the same number of species, not quite, there's less, but the total number of butterflies you're seeing is about half what it was 30 years ago when we counted. We started doing this for fun. We love butterflies. I had a bunch of butterfly lovers get out and take a look at what's out there. And unfortunately, it has turned into a sad thing, because this is what we're seeing over that amount of time. Now, this has been done I think in 2022, there were 382 counts like this done nationwide. 350,000 butterflies were documented in that 1 year alone. So we're definitely seeing the results of, you know, the whole entire North America. We're not just counting Victor's backyard. And with that many counts over that many years, our longest counts in New Haven go back 50 years. We're getting a real picture of what's happening to insects in our environment. And if you think you used to see more butterflies, you did. Here's the proof of it. Here's the metric right here from Connecticut, Reading, Connecticut, right from your backyard. Next. So that's my talk, just to give you an idea of where some of those numbers are coming from, that they're graphing us to death today in this room. Thank you.
Thank you. What a eye-opening day. Thank you all for having me here, inviting a farmer in to talk to you. I admit to being a little on the fence about coming because so much of today's talk has been about how farmers are really the perpetrators of this. It is farmers who are putting down this seed, and I'm not one to break ranks. And so it's hard for me sometimes to show up as a farmer to events like this, knowing that so many folks in conservation find themselves on the other side of an aisle that doesn't really exist. And so I was heartened in many ways to see the number of slides that alluded to the reality that I live in, which is that farmers are on the brink of extinction. We're doing what we can to survive, just like all of these bugs you've seen. And that the real perpetrators of what's going on are these huge, big chemical companies. And so I'm glad in so many ways that I saw those slides coming up to say, this is actually just another method of selling more chemicals. It's not about growing food. And so though I am not one to break ranks, I am here and wanted to talk to you a little bit about my farm. And I have the advantage today of being an organic farmer. And so I'm here to tell you all the good news. You've heard a lot of bad news. And maybe that's why Louise put me at the end of the day. I should say the other really convincing reason that I'm here and that I decided to come is because Louise asked me to. And when Louise Washer asks you to do something, you do it. So a little bit about these photos. First, as an organic farmer, about 5 years ago, started getting very concerned about the issue that we're having with pollinator services in our farms. I recognize in a absolute way that these butterflies and bumblebees are signing my paycheck every 2 weeks. And so we need them as a matter of an existential issue on our farms. And there's a picture up there of my blueberries I included. And those blueberries took me on a very interesting journey as an organic farmer. About 15 years ago, we established that flock of chickens. And so when people say, oh, I love organic food and I love organic farmers because they never use pesticides, I'm here to say those chickens are some of the best pesticides that we have, in that they are turned into my blueberry patch at the end of every season. And rather than try to control for bugs with chemicals, I control for them by letting those chickens in. They run around under the blueberries, eat up any of the pests that would harm next year's crop, completely sanitize that field. Simultaneously, they are a fertilizing machine as well as a pesticide machine. And off they go with the field perfectly prepped for the next year. And the result is my community gets a fantastic source of good protein through their eggs every day. And so it is functioning as a pesticide and functioning as organic fertilizer. But the funny picture on the bottom, and I want to be quick because I know we have time for questions, is that about 5 years ago, when I started talking to farmers about pollination services and how the pesticides and particularly the neonics and the systemic organophosphates were really taking their toll on our pollinators, it was really hard to get farmers galvanized about that because we don't necessarily see a lack of pollination services. I plant tomatoes, I get some tomatoes. I plant cucumbers, I get some cucumbers. But when I started talking to them about that little picture at the bottom there, and you can just see that is some swamp milkweed that is being attacked by aphids. See those little horrible, you know those, yep, you very educated audience. But hanging under that leaf, does anyone know what those are? Yeah. They're lacewings, and they are like like the nastiest soldier bugs you could possibly get. Those things will hatch and clean up the entire farm. There won't be a spider mite, there won't be anything left when those guys go to work. They are the soldier bugs that we need to do the pesticide work for us. But without those native plants, and when obviously you spray a pesticide, you kill all the bad bugs, but you kill all the good bugs too. And so many years ago, Mary Conklin from the Yukon Extension introduced me to these beautiful lacewing eggs, and each egg is sort of suspended on a little filament there. They're so beautiful. And so just simply fostering that biodiversity, fostering as much life as I can on my farm, manages to control for anything that would be potentially out of balance, like those pest pressures. I know we are going to have panels, so I'm going to sit down, but any questions you have about pesticide use farms, and in particular, how to grow good blueberries, I'm here for you.
Hi, my name is Bert DeMarsh. I'm the owner of the Laurel Rock Company in Wilton, Connecticut. And similar to Dina, I was asked to come here and I was a little bit hesitant. But I also was eager to let you know that there are landscape contractors, landscape professionals out there who do believe that there's a different way to do things, and you just have to be progressive in your thinking. But I want to give you some insight today into how neonics are in the landscape industry, like what we use and why we use them, and just get an understanding, and also some of the challenges that we face in information flow into and out of the landscape industry. So I'll start by just talking about lawns. That's a big part of it. We're not going to have any other slides in this, so I hope that's not too boring for you. Imidacloprid, we use a product called Merit, which you've probably heard of. That's the one that is used widely throughout the landscape industry. It's effective against at least 12 different insects in the lawns. You've heard of grubs, chinch bugs, Japanese beetles, bill bugs. These are all very common, and we find them every year on some of our properties, not necessarily all of our properties that we maintain. We maintain approximately 150 properties in Fairfield County. It's utilized as a broadcast spray. It's frequently put down as a granular application on lawns. And typically we're applying that in July because it is specifically used for grub control, and it's used as a preventative, which we'll talk about in a minute. We also use Merit on many ornamental plants and many trees. You heard earlier about the ash borer and the problem with that. The emerald ash borer, it's used on that. It's actually 20 different insects on trees and shrubs, including woolly adelgid on hemlocks, which you know that's been a problem. You may know that that's been a problem for decades. And now it's more under control. I mentioned the emerald ash borer, which has been a huge problem. I moved onto a property in Fairfield and had to take down 30 trees that were all dead, and they were all ash trees as a result of that. Aphids on viburnums are very common, whitefly on azaleas, and psyllids on American boxwood. American boxwoods are probably one of the most popular plants right now because the deer just don't eat them. But psyllids are a big problem on those plants. These are applied typically through in May, June, and July, and they're applied frequently as a foliar drench or a foliar spray onto these plants. So there's a question about preventative versus curative. So the one question might be about IPM, integrated pest management. Integrated pest management is based on thresholds and based on inspections. And if you don't have a certain threshold of an insect, then you should not be applying, right? There was also an example earlier about dollars, which I thought was kind of an interesting concept. If it costs less to replace the lawn than it does to spray it, then do so. And I would say that in the residential, high-end residential landscaping, it's usually not acceptable to say, well, you're just gonna have to replace the lawn because we're gonna let the grubs eat it because we don't want to put this down. That's usually not something that a client will listen to. So we actually do a lot of Merit application as a result of having to put a preventative down for something that typically will happen. The majority of years, we do have some form of grubs in the lawns. When it's not treated preventively, the other application that we would have to put down is on an infected lawn is an organophosphate called Dilox. And many of you know organophosphates and the effect that those have. So the question is, which should we do? Should we put down the neonicotinoid or should we put down the organophosphate? Because one way or another, we're going to put something down, most likely in order to cure the problem of grubs. So this is one of the conundrums that's being faced by landscape contractors in trying to please their clients. some conflicting information is also out there in the resources that many green industry professionals, when I say green industry, I mean like landscape companies, lawn care companies, what we rely on for knowledge. So something came out literally last week as I was preparing for this, and it's a legislative alert from CNLA, which I'm a member of, Connecticut Nursery and Landscape Association, which is a great group and very supportive group. It was concerning the State Bill 190, and it stated in here, as drafted, this bill could lead to the use of alternative products that are less effective and pose a greater risk to pollinators. This is about the neonicotinoids. It could pose a greater risk to pollinators, the environment, and the public. Simply put, the alternative non-neonicotinoid products are more deadly to pollinators. So that's the information being given from a trusted organization to landscape contractors last week. Now, acelepryn is also sold as Grubex to homeowners. It's the most common alternative right now, the product on the market as a non-neonicotinoid. Okay, so just as a point of information there. Now, if you read another one group that we listen to a lot is UMass Amherst. They published an article all the way back in 2013 that stated acelepryn and Grubex have very low toxicity to vertebrae and no activity against bees. So they're saying that, and that's from UMass, and then up here from CNLA, they're telling us that potentially that would be the product they're suggesting we use, and they're saying that's going to be worse and be more deadly to pollinators. So that's kind of confusing. And then we look at the EPA as recently as 2019 stated, quote, in general, we can say that neonicotinoids are that selective brand or chemical class that we've been looking for as a positive statement, right? So this is like some of the intake that we get. So hearing a clear message would be really helpful to landscape contractors of what are we supposed to be doing? Because Merit was like the answer to all of this, right? And then, you know, the more I talked to, did I mention Tara? I think I did. Tara Cook-Littman, who's a good friend of mine and who's really educated me a lot about all these products. You know, I'm saying, maybe it's not quite the answer I thought it was. So that's just one point I wanted to bring up. And then the last point being challenges in label instructions. So one of the things about being a supervisory license at the state of Connecticut for pesticides, you have to really truly understand how to read the label. And the label is typically about 25 pages of detailed information for every pesticide. And there's also advice from trusted institutions like the ones I mentioned above. So on the product label for Merit, for instance, there are 2 pages regarding protection of pollinators. Specifically, they have a B and a cross through it and saying like, bring attention to this. And under the title, it's called Application Restrictions. It states on the label, do not apply Merit insecticide while bees are foraging. Do not apply Merit insecticide to plants that are flowering. Only apply after all flower petals have fallen off. And then you have a study from Cornell that recommends only spraying Merit in the evening or at night to avoid contact with foraging bees. So I'm trying to put these things together and say, when exactly am I supposed to apply this? Like I can't pay the guys to go out and spray in the dark. And I also can't, you know, exactly follow not spraying it when things are flowering until every petal is dropped, because that's going to take away the entire time that I have to apply it in order to be effective. UMass Amherst warns to not apply Merit on lawns when clover is flowering in lawn areas. So that flowers for months in lawn areas. So none of these restrictions are really feasible to ask professional applicators to follow. And we have to apply prior to plants being infested, which means when the bees are foraging, and our crews cannot, like I said, apply at night. So again, those are challenges I would say we're facing. And I'm not here to complain about this. I'm just here to say, I think that there's information that's very contradictory out there that's being received by landscape contractors, many of whom unfortunately are not as educated around things as I might be or as some of my peers might be. And they're just taking it. And if you ask, honestly, the question before, go ask your landscape contractor what they're applying, many of them will say, well, I'm not exactly sure. That's just the truth. So I think that there's a lot of education that has to occur there. So in conclusion, the use of neonicotinoids, specifically Merit, in lawns and ornamental plants presents a complex challenge for green industry professionals. These insecticides offer effective control against a range of pests, makes them a very popular choice for preventive treatments, and their use does raise concerns about the impact on pollinators, such as bees and the environment at large. The conflicting information from various sources further complicates our decision-making for professionals and seeking the best approach to pest management. So while some argue for the necessity of neonicotinoids due to their efficacy and selective action, others, like myself, advocate for alternative products with lower risk to pollinators. Navigating label instructions and recommendations from trusted educational institutions does add another layer of complexity. And balancing the need to limit harm to pollinators with the imperative to control damaging insect poses significant challenges for applicators and for our clients. So ultimately, I think it really is a collaboration of the stakeholders, right? The policymakers, researchers, industry professionals, and environmental advocates. We need to develop some clear guidelines and alternative strategies that prioritize both pest control and pollinator protection. And it's essential for sustainable landscape management practices going forward. Thank you.
Thank you to all of our panelists. We do have some questions for you. So for Karen, and there are microphones there that you should be able to turn on. Oh, yeah, okay. For Karen, why were there so many detections in the summer in the Norwalk River? For Karen,
Detections of imidacloprid in the summer. It's essentially, I don't know, is this working?
Yes.
There we go. That's essentially when the highest use of that particular constituent is used. So.
Okay. Yeah, it's pretty much lawns. So it's used on lawns during the summer growing season. Oh, got it. And then for Dick, somebody asked, they didn't catch what was put into the drains in New York. Was it permethrin?
I'm not sure exactly, Method is what I heard.
How can a large landowner who leases Connecticut River floodplain farmland to a local farmer that plants corn and uses pesticides find a better organic farmer? Dina, I think that goes to you.
There are a number of ways. One of the best organizations in Connecticut for doing that is called Land for Good. And I highly recommend that you connect up anybody who has land and is looking for a farmer to connect up with them. There's also, of course, Connecticut NOFA, which I can always put a plug in for, that is part of a program run at the state called Land Link, which does something very similar.
Keep the microphone, Dina. Do you have any thoughts on how we can shift policy away from subsidizing big ag and switch that to subsidizing organic farms?
I have a lot of thoughts about it. It seems like a long question. I think some of it has to do with the Farm Bill, and Dr. Stoner is there in the back working on some of those issues as that comes into play over the next year. Most of the Farm Bill money is really not slated for this kind of production, and so it is going towards the larger commodity crops. You know, I started farming 20 years ago when Obama became president. He took a little bite out of that huge, big Midwestern corn subsidy and earmarked it through the NRCS, the National Resource Conservation Service, for young, transition to organic, and underrepresented farmer class. And with that stroke of the pen, it put me in business because the NRCS, I was young back then, and I was able to, you know, put up the necessary fences. They gave me a little bit of help and floating me money to dig wells, things like that, that made a huge difference. And without that, you know, 10-foot deer fence, I'm really not farming. You're not farming in Connecticut.
Thank you. Bert, you have a couple of questions. After learning that neonics don't work, are you going to stop using them?
No, I had no idea. So they do work, actually. It's just that they're not good for a lot of other things. So yes, we are going to stop using them, and we are actually actively looking at, and that's why I was also a little concerned about coming. We're not getting stopped yet. So we are stopping, and we are talking with our applicator about other products that you can use. So
We have a couple of questions about grub control, like using nematodes, and your thoughts on that.
So we've done some research on that. I did more years ago on that. And we found it doing some properties, actually, including my own. We did some studies, and we had not nearly the results that we needed. And again, because we're dealing with a pretty highly educated consumer who also is highly demanding typically. And so it unfortunately was not working for the people that we were serving.
Which leads into the question of how do we get people to accept the less perfect lawns?
Well, I talk a lot about clover being a good thing, actually. I don't know, there are people, just to give some, so there's still faith in other people out there. Not everybody wants a perfect lawn. We do have some clients, one of our largest clients actually, spends well over $100,000 a year on maintenance on her property. And she's fully organic and she has an organic vegetable garden. She has orchards. She had bees for a while. Actually, we had such a hard time keeping the beehive. She replaced them multiple years in a row and finally said, I guess that's just not gonna work. So that was frustrating. So there are people out there that are looking for that. And most people that we maintain properties for are on a sustainable turf healthcare program, which means that as long as they're willing to take the risk, right? So say risk. We do say that we will not do a preventative unless you require us to. We can do a curative. The curative is something that is, organophosphate, which is not terrific. Here are the reasons that's not terrific. And so try to give them an understanding of the difference between those things. But most people, I haven't found anybody who's saying I'm willing to let the grubs just eat whatever portion of my lawn they need to, and then I'll just resod later. That's unfortunately, it's just not out there yet.
So for Victor, how much butterfly loss is due to habitat loss and changing temperatures?
Well, as I said, that's a very hard question to answer because you have to separate two different things. Where we're seeing habitat loss is really invasive plants coming in and replacing the plants that were there that might have been food plants for the caterpillars or something like that. And one of the great sadnesses of doing something like this for 30 years is you are really chronicling that process. So invasive plants have had a big impact. We've managed to save our meadows to some degree in Reading. There's still outstanding meadows. What's climate doing? Well, we've seen some new arrivals in Connecticut in recent years, which are probably due to climate change. The giant swallowtail, which is a spectacular, huge swallowtail, is now becoming very present in Connecticut, most likely as a result of climate change. And interestingly enough, the new ones we're getting in Connecticut have been traced genetically to giant swallowtails in the Midwest, not giant swallowtails farther south. So the migration into our area seems to be coming from that direction, which was unexpected before they did the molecular analysis. But climate change is going to cause changes in the species available to us, but we're not sure yet what that's going to be. It's coming.
We have a few people that are calling for smaller lawns and Bird, are there a lot more families that are talking about smaller lawns and more pollinator areas?
So, so actually one of the things we also do design build work, and one of the things we recommend frequently on properties, especially over 2 acres, but we have one that's only a ½ acre in New Canaan. They actually don't want any lawn at all. They're looking for just all meadows. And we're like, this is terrific. And then we talk about native plants and they go, that sounds great. So, and they're a 30-year-old couple, in their early 30s. So that's pretty exciting to hear. But we weren't 10 years ago, we were very rarely getting those type of requests. But you find that if you talk about meadows, and for some of the husbands we talk about, it's similar to when you're on the golf course and you're looking to the left and you see the low fescue, that's that grass that flops over and kind of looks very uniform on the left and right side of your fairway. And they're like, oh yeah, I know what that is. I said, that's a type of meadow. And then they go like, oh, I like that look. So, okay, good. We got bought in on that. That's good. So it can be helpful to have people that go on golf courses sometimes. Anyway, we do perimeter meadows. We're doing another one in New Canaan right now. We're going to do a perimeter meadow against the hedge that was put in before we were there of green giants. And then we're going to have a lawn inside of that. So it'll just less lawn. They just don't need all the lawn that they have necessarily. So that is, I would say that is definitely an uptick on that trend.
Right.
Can I just add slightly to that? We've let our lawn go, so to speak, and you might have seen it in pollinator pathway as let it. And we have now tons of clover and hawkweed, and then I cut it the 1st of July to bring it back to a regular lawn. But I've been monitoring since I started that years ago. We are getting so many pollinating bees, different species of pollinating bees, a number of butterflies, a number of other insects reinvading the area. So you're going to see a great leap in biodiversity if you cut down, we never used chemicals, but you cut down and you go for the clover. The clover is just a tremendous pollinator jump starter.
Great. Well, I want to thank all of our panelists for coming out and joining us today. So the research clearly shows a correlation between neonicotinoid use and decline in birds, bees, butterflies, and pollinators. We've heard about the research, we've heard about the challenges that are felt by farmers, organic farmers, as well as our landscapers. There's a lot of information that we can be sharing. And we feel that the time to take action is now. And you're all here today and you stayed here for the full 4 hours. Thank you, or 5 hours, I'm here now. Connecticut has the opportunity to join states, as Anne said, New Jersey, Maine, Nevada, in banning the use of neonics in non-agricultural uses, or following in the footsteps of New York and becoming another state that bans it in agricultural uses as well. This and we can't wait for EPA. We just can't. Their funding is too low for them to be doing these reassessments or to be assessing new. And Fish and Wildlife, which is required to assess pesticides through the Endangered Species Act, they're underfunded. So as Hardy said, 2 pesticides, 2 made it out of Fish and Wildlife. I mean, we can't rely on them giving us that safe information. We have to rely on them because, of course, they certify and they certify all the pesticides and chemicals. But that doesn't mean that Connecticut can't take a stronger stand. So you standing up and stating that. As Anne said, you can still write to your legislators. You can join Anne on Friday, right back here in Hartford. And make your voice be known for considering SB 190, but with the modified language. The way it is now, it doesn't do anything more than what we currently have. So please join me in thanking the Connecticut Coalition for Pesticide Reform for helping to coordinate this. Pollinator Pathway, Connecticut Audubon Society, Rivers Alliance of Connecticut, Sierra Club, League of Conservation Voters, American Bird Conservancy, Save the Soundkeeper, Clean Water Action, Catskill Mountainkeeper, Laurel Rock, and East Norwalk Blue. Thank you so much for joining us today.